Hello, namaste. Welcome to the second edition of HashiTalks India 2023. My name is Gaurav Sharma and I'm joining you from Pittsburgh, Pennsylvania, United States. Hari and I will be your host for today's event. And we have Jasmine in the background, who's our community manager, kind of like powerhousing this event. We are really excited to be here and we welcome you all. I'm a software engineer, I'm a senior software engineer. There is some issue. Yeah, sorry about that. Uh, I'm a senior software engineer at HashiCorp, nearing my 2 years with the company. My team works on building Vault as a managed service in cloud, also known as HashiCorp Cloud Platform. Over to you, Hari.
Thanks, Gaurav. Hey, everyone. My name is Hari Ram Sankaran. I go by Hari. Namaste and Vanakkam. I was born in Chennai, raised there for a while, and then I moved here and live in California now. I'm a solutions architect here at HashiCorp. I've been here about 2 years as well. I am passionate about solving customer problems, but I'm also their voice and help use that to shape our products. I'm especially very passionate about console and solving a lot of the SOS networking problems. Thanks, Gaurav.
Great, great to have you here. If you have questions or comments throughout the event, we would love for you to interact with us on the YouTube chat. As you do, please ensure that you keep in mind our code of conduct in the virtual space. In general, be welcoming, inclusive, friendly, and patient at all times. Be considerate, be respectful, be professional. You can also read about our code of conduct at hashicorp.com/community dash guidelines. And we really want you to have a great time today. With that, let's get started. We have an amazing lineup of speakers for today, and I'm really excited to learn from all the interesting use cases and integration that the community is doing with HashiCorp products. On that note, Hari, what are you excited about for today?
Likewise, Gaurav, I'm really excited for all the products and the use cases and that is about to be spoken about, and I'm just happy to be here. I'm also excited to continue this tradition with Hashi Talks. We have some upcoming news on other Hashi Talks, so please stay tuned. We'll give you information as we go along today.
Without further ado, let me call upon our first set of speakers, Tanya and Amit, who are working as software engineers at Bintra, and will be walking us through their topic on secret management through Vault in a zero trust architecture. Over to you, Tanya.
Um, yeah. Hi, everybody. I am Tanya, and we will be speaking on the topic of secret management through Vault in a zero trust architecture. Okay, so before we move on, just a brief introduction about the speakers. So my co-speaker is Amit, and we both are working as software engineers in Mintra, and we are part of the platforms team who actually takes care of all the uh, tools and infra-related tasks of handling say logging systems, secret management, authentication, authorization, and all. So, without further ado, let's get started. So, today we will be majorly focusing on two aspects here, which is one is secret management, and the other being zero trust architecture. We'll walk you through how secret management in microservices should be actually on a high priority in any organization's list, and how management of secret in a zero trust architecture can be challenging, and how we in our organization have tried to solve these challenges. So let's start with first the problem statement. So uh, in a traditional network security models, earlier what used to happen was that people would establish a kind of a boundary, or that we call as a perimeter, majorly in in case, in the sense of a firewall, and then trust anything that made past that initial barrier. As in, there was a binary distinction of what is inside that firewall can be trusted, and whatever traffic that comes from outside cannot be trusted and is supposed to be not gone ahead with. Whereas now, when we talk about the cloud environment, we are moving away from the static IP based model. We are actually moving away from this distinction at the same time, because the environment is so much dynamic, that and more and more it is becoming more and more ephemeral. We're launching new VMs as we go, as we are launching new workloads up and down as we even speak. So it is very hard to manage this static set of IPs, and that is why we are actually moving towards something known as a zero trust model. So what is a zero trust model here? So in a zero trust model, that binary distinction of whatever is inside my network is trustworthy, whereas whatever is outside my network is untrustworthy, that notion goes away. So what happens is that in zero trust environment, all the users are treated as untrusted, regardless of whether they're inside or outside the network. That means that every user, every workload has to be authenticated. Even the nodes or the devices on which they're running have to be authenticated and given an identity. And the after your device and your workload is given identity, based on that, we have to restrict the access to the resources uh, whenever we're granting any kind of access. So this is what the zero trust model is based upon. Now, when we talk about how we wish to manage secrets in a zero trust environment, I'm sure you guys would have already anticipated how the challenge in a very dynamic environment will come up, as in each application might be managing their own set of secrets, their own set of certificates. So it becomes really difficult if each application is taking care of their own secrets, and more areas to be prone for the attackers to actually get a hold of these secrets. So that is where the HashiCorp vault comes into play. So vault is a system that will centrally manage and enforce access to the secrets, and your application uh, is no longer required to manage their own secrets. We have a centralized place where we can um, manage all the secrets. So let's see in detail, like how, like what are the challenges that are coming for when we talk about secret management, and how we plan to solve them. Okay, so whenever we talk about distribution of secrets in any network or in any environment, these are the major areas of concerns that any organization might have. Who has the access to the secrets? Who will manage the secrets? And how will I control, or how will any person or the security team control that what secrets can be accessed by what apps or what users? So uh, these points actually are the major areas of concerns whenever we want to design or leverage any secret manager that is present in the industry. So let's talk about more into what is HashiCorp Vault. So basically, HashiCorp Vault is a system that will help in managing your secrets centrally by securing them, storing them, and also providing them a tightly coupled access to the tokens, the passwords, the secrets It also extends capabilities of encryptions for protecting your secrets while they are sitting in your database. And all of this can actually be achieved using a UI or a CLI or even HTTP APIs. And the Vault, HashiCorp Vault, basically has multiple versions available in the market. The one that we are using in Mintra is actually the enterprise version. So just let's talk about few points of how and what all features of the enterprise version are we leveraging in the company. So as you all know, secret management, that is the core feature, and is present in both the community version as well as the enterprise version. Now there is something known as identity based access, which actually enables, which helps us in enforcing the zero trust that we talked about sometime back. How it does is, and what actually happens is what we'll be talking about in our further slides. Uh, it also exposes the feature to actually encrypt your data and basically exposing encryption as a service, so that all so there is a centralized place where you can just send me the data, and Vault will do the encryption for you and give you back the ciphertext. It also has improved scalability, where now we have something known as the performance standby nodes, so which are actually helpful for horizontal scaling of read requests. So your read requests and write requests are actually scattered between your leader node or the active node and your performance standby nodes. And there are multiple such features that are offered. However, based on your use case, you can leverage what is required by your organization. So let's move ahead, and yeah, let's talk about how we are enforcing zero trust using something known as Spire. I don't know how many of you are aware of what is Spiffy Spire, but I'll just give a brief introduction. We will not go into much details. However, the brief knowledge is necessary to understand the further working of the systems. So let's start with something known as, so basically Spire is an open source project available. It is actually done by the CNCF company organization, and what it does is it is basically used to provide an identity to your nodes as well as your workloads or services which are running on your nodes. So now that identity is provided in terms of what we see here is Spiffy ID. So if you see, it is a standard format for a service identifier. So the format goes something like Spiffy followed by the trust domain. Now, what is a trust domain? Trust domain is something that you formulate within your organization. Say, for example, any request coming from the trust domain, any request coming out of this domain will not be considered as valid or authenticated. So this is what a Spiffy ID looks like. Now moving on to SVID, which is Spiffy Verifiable Identity Document. So when this Spiffy ID is actually cryptographically signed by some asserting identity, we call it a SVID. Now that asserting authority, in our case, is known as the Spire server. So whenever a Spiffy ID is actually signed by my Spire server, it converts into a SVID. Now, your SVID are of two types. One is your X509 certificates, or the other is JWT tokens. So, in our case, we are using JWT SVIDs for service to service communication. How that is happening, we'll see in the next slides. Uh, yeah. So just to reiterate as to what and how a workload can get its own identity, what happens is that the first step is that the node, your be it your Kubernetes pod, be it your VM, wherever your service is running, that node is given the identity. As we discussed that in zero trust model, we even need to authenticate the devices on which your services are running. So the first step is to get the identity of those nodes. The second is, once I get the identity of my node, then we move on to getting the identity of my service. So yeah, if you see this diagram on the right side, what happens is that on each node there is something known as a Spire agent running, and where the service is also sitting. So this service will get the identity from its Spire agent, and based on some pre-validations, some checks, this agent will send that request to my Spire server. If everything goes fine, like if my agent has been verified, if my service has been verified, if all of those go fine, then this service gets something known as the JWT SVID that we talked about in the last slide. So even in our use case, every service has its identity in form of JWT tokens. And whenever my service A wants to connect with my service B, it will be presenting that token as an identity. And that service B will again validate if that token provided to me is authentic or not. So this is how we have given each identity to a service. Now see, now my service, my all the services have their own identities. They are capable of validating, uh, validating the tokens, validating each other's identity. Now, how we are doing secret management on top of this layer? So what we have built is an in-house middleware service between our workloads and between Vault to facilitate their interaction. So how this facilitation is happening? Basically, we have built an abstraction layer that will take care of all the necessary overhead which might be needed to you know leverage Vault as a secret management manager. And what are these tasks that are needed to be performed? We'll be talking about in the next slide. So using this middleware service, I will be having a single entity where with which I will be able to perform a uniform governance and policy enforcement across all the services that are running. And for zero trust, that we saw how we are actually giving an identity to all the workloads, but how we are enforcing them while accessing secrets, we'll see in the next slides. I'll hand over now to Amit, my co-speaker. He will be walking you through the design of this middleware service.
Thanks a lot, Tanya. So, as Tanya has already introduced you to the middleware service, I'll briefly explain the HLD diagram of how exactly it is working. So, as you can see, it has a lot of components, and any service can connect to the middleware service and finally fetch the credentials or maybe use other features we are providing. So let's start with the components. I'll start with the bottommost layer. First, we have this health manager. So it's like all each of our component have its own health manager. Vault has its own health check APIs. Authenzy has its own health check APIs, and there is a overall health check API for the complete middleware. Then we have some alerting and logging engines. Logging is basically used for logging purposes, and alerting is alerting via over a New Relic and whenever there is a failure or something. Then coming to the other components, we have environment handler. So basically, every company has multiple environments, dev, pre-prod, prod environment, and our vault setup is different in pre-prod as well as prod environment. So to prevent the access from pre-prod to prod, we have this environment handler which takes care of all these access and everything. Then we have the lease manager. So middleware service itself has to connect to the downstream vault to fetch the credential on behalf of other services. So it has to have some authorization and authentication system. So it is the job of this lease manager which fetches the token on middleware services behalf and refreshes it and uses it to fetch the to connect to the vault basically. Then we have authentication as well as authorization engine. This has already been explained by my co-speaker, the Spiffy Spire, which we have been using. So we'll move to Vault Broker. So Vault Broker, basically, this is the layer which is responsible for connecting to HashiCorp Vault. So this is the layer which connects to Vault via its own HTTPS APIs and perform all the features. Then moving ahead, we have this control plane. Control plane is basically the brain of our middleware service. It redirects all the requests to certain components on the basis of their payload as well as headers. Then moving forward, we have this REST API layer. So this is the exposed layer which is exposed to all the services inside Mintra. Basically, it has all the endpoints through which you can connect to the middleware service and perform the functionalities we are providing through the middleware service. So this is the overall high level design of what middleware service has, its components and how it is working. So I'll move forward to briefly explain what all the features which our middleware service is providing. So these are basically extended from Vault itself. So the first feature which we are providing is sensitive data encryption and decryption. So we are providing sensitive data encryption and decryption as a service. This means that service can send, all the services can send the plain text and we'll return them the ciphertext in case of encryption. So basically to ensure that no service can decrypt any other service's ciphertext, we are using service name basically and the SVID token being passed in the header in the encryption path itself. So Vault basically encrypts and decrypts and does all the features, all the jobs basically to a certain path. So we are storing the service name as well as the SVID token there itself so that no one else would be able to decrypt other services ciphertext. Moving forward, we have sensitive data read and write. So this is also path based, that the services need to provide their service name in the secret path where they are storing their sensitive data, and we are saving the service name there itself so that no other service has authority over some other services data. Next, we have dynamic DB credentials. So basically, let's say a service wants to have credentials, short-lived credentials over a certain period of time. So HashiCorp Vault has this feature as well, and we have extended this to provide DB credentials for a certain TTL. And then we have key rotation feature as well. Basically, someone wants to rotate the keys, and that is also we are providing. So moving forward, I'll explain you the sequence diagram for sensitive data read API from Vault, which is using our middleware service, which is inbuilt. So we have certain components, upstream service, which will be gonna connecting to our middleware service. Then we have Auth-NZ to authenticate and authorize the request. And then we have our downstream vault, basically, which has all the credentials and the service is trying to read it. So the endpoint exposed is slash sensitive data slash kv slash read. So any upstream service basically can connect to our middle stream using this API. This API consists of two parts. One is the header and one is the payload. So header basically consists of your Spiffy SVID token. So this is used to authenticate the request. If this SVID token, let's say, is invalid or expired, then our system will return 403 unauthorized access. And then we have our payload. Payload consists of the secret path basically from where you need to read the data. This secret path also contains the service name. So how we are authorizing is that the service name in the secret path must be exactly same to the service name we are getting from the SVID token to SPIFFY ID. So only if they match, then it is authorized. If there is a mismatch, we again throw a 403 unauthorized error. So once this all authentication and authorization has been done, verification of SVID and everything, our middleware service calls the downstream vault through its HTTPS APIs and fetches the secrets on behalf of all services for them. Once the secrets are successfully fetched, it gives a 200 response back to the upstream service with the data what they were trying to read. So this is how the flow of sensitive read is within our middleware service. So basically all other services are similar to this, and we have exposed certain endpoints, and the flow is quite similar to this. So moving forward, so what we have explained now, how services are authenticating and authorizing themselves to the middleware service. The thing left is how middleware service authorize and authenticate itself to the vault to fetch the secrets or provide the features on behalf of other services. So for authentication of middleware service, Vault has its own identity-based access. So Vault has certain number of auth methods like K8's Kubernetes auth methods, Azure auth method, OIDC, and a lot other auth methods. Inside Mintra, we basically have a hybrid architecture right now. The services are running on both Kubernetes environment as well as Azure VMs. So we decided to go with a hybrid environment setup for this middleware service as well. So I'll briefly explain the Azure auth method. K8's method is quite similar to it, just that instead of Azure JWT token, we have a service account JWT token, which is used to authenticate the middleware itself. So how Azure auth method works is that let's say the middleware service is hosted on an Azure VM. So it has to first log in itself to Vault and fetch a client token, which it can use basically to serve the HTTPS requests or serve the features which the upstream services are asking for. So it will first fetch the JWT token from Azure open endpoints. Once the JWT token is fetched, we hit a login API. Vault has its own login API, HTTPS login API, along with the metadata and JWT token. We pass it. Then Vault verifies if the token passed is correct or not. Once verified, Vault returns a client token basically to our middleware service, and that client token can be passed in the further Vault requests to complete the feature requests. So this is how the middleware service is itself authenticating to the Vault service. So why this is beneficial? Now we have taken all the load from the services to manage their own to not to authenticate to Vault, and it is job of this middleware service just to complete the request on their behalf. So now moving forward, Vault, a middleware service itself has to authorize itself as well. That whether it can read certain paths, where it can decrypt or encrypt certain paths or not. So for this, basically, Vault uses policies to govern the behavior of clients and instrument RBACs, role-based access control. So that is how Vault provides this. So we are using Vault policies, defining a list of paths for our middleware service through which basically it can access certain paths, perform read, write, or delete operations on them, and no service except middleware service can do these things. So that is why this is completely the job of middleware service, and it is a bridge between upstream services and downstream Vault. So this was how middleware service itself authenticates as well as authorizes to the to the downstream Vault. So coming to the highlights of the middleware service, what exactly and how this is beneficial. So first thing is ease of integration. So we have around 500 services plus inside Mintra. No, it can't be go like this that each service connects to Vault on their own and tries to perform the credentials. There definitely has to be some middleware or central service which can do this on their behalf. And since we have exposed a lot of endpoints for this purpose, This integration is quite easy for all the services. Just hit the APIs, send the SVID token, and get 200 response. So then we have automated through our lease manager. We have automated vault token and refresh and basically refreshing is also automated. And now it has offloaded all the jobs from application to the middleware layer. And next is zero trust enforcement. As already explained, using Spiffy Spire, we are providing zero trust enforcement. Then coming to the availability of this service, we basically have a hybrid model, which it is running on both Kubernetes as well as VM environment, and we are trying to provide the best availability possible. Then coming to the reliability part, we have a dedicated health check module to constantly monitor the health check of all the underlying systems. We have New Relic and Zenduty alerting, and we have been using all these alerts in case of any failure scenarios. So this is how we are providing the reliability for our middleware service. I think this is all what we had. And if we have any doubts, we can definitely go to the Q&A section.
Awesome. That was a really good talk. It's never easy to go first. Tanya and Amit, both of you did a phenomenal job. I especially loved how you touched on Spiffy and Spire. Those are not easy concepts to talk about. Here at HashiCorp, we talk about zero trust quite a bit. And that identity, that layer 7 identity, is what's most critical. There were questions about how Console and other tools use it. Yes, they do use it. Console helps with protecting the networking portion. So you can leverage Spiffy Spire identity to do the same with Console as well. So awesome talk. I loved how you touched on all of those very important information. We're going to switch a little bit to our next speaker and move towards infrastructure as code concepts. So for that, we have our next speaker, Kamalika Majumdar. She's an independent consultant and has a wealth of practitioner experience around infrastructure deployment and DevOps principles. And she's going to talk to us about building an ISO compliant data center recovery center with Terraform. So off to take us away, Kamalika.
Introduction. Hello everyone, my name is Kamalika, and today I'm going to talk about building an ISO compliant data center and data recovery center on with bare metals using Terraform and VMware. So without any further delay, let's get started. First, let's understand what is ISO compliance. When I say ISO compliance, I mean ISO 27000 compliance. It is an international standard to manage information security. The full form of ISO is International Standardization Organization. This is an organization that releases standards for various practices that organizations should follow, be it information security, infrastructure security, etc. So here in today's session, we are going to be discussing about the ISO 27001, which specifically talks about information security of for your organization. So what is the background of the project? So the background here is that one of the leading financial services institutions of Southeast Asia wanted to go live with their applications, and for that they needed an ISO 27000 compliant infrastructure, which had an RTO and RPO of 4 hours and 15 minutes respectively. So if for those who are unaware of the term or new to the term RTO and RPO, RTO stands for recovery time objective. In short, how fast you can recover in an event of a disaster or disaster-like scenario. RPO stands for recovery point of objective. That is how much you can recover when a disaster happens. So for this instance, RTO of 4 hours means in an event of a disaster being declared, you can recover from the disaster within 4 hours. And an RPO of 15 minutes means you can recover, let's say the disaster happens now, so you can recover the data up until 15 minutes from now.
So that's the overall definition of RTO and RPO. So this project was about building an infrastructure with an RTO limit of 4 hours and RPO of 15 minutes. So basically, the objective was to build a fault-tolerant infrastructure following the ISO guidelines. Now, the next question, or usual question, which comes in when a requirement as critical as this comes, why did we go with a DC or a DRC, or in other words, an on-premise data center? Why not a cloud infrastructure? So the reasons are, this project was based out of Indonesia, and Indonesia's financial services, like many other countries, requires its customers' PII data to be localized within the country. So the data cannot leave the country. And that is why the applications had to be hosted within the country. And all of on ISO 27000 needed that it met the RTO and RPO requirements for disaster recovery. And they also had an SLA defined of 99.95%. And at that time, there was no certified cloud provider available in Indonesia, which can meet the Financial Services Regulator or OJK requirement. So the entire setup had to be done on a traditional data center and data recovery center, as we used to do in the good old days or pre-cloud days. And these data center had to be located at least 40 kilometers away from each other. So at least they should be located such that they are not within the same disaster prone zone. Otherwise, disaster recovery would not mean anything if they are just sitting side by side, which is the case with many cloud providers in some regions, that though they have multiple regions or availability zones, but the disaster recovery and the data centers and the disaster recovery conditions do not meet their physical co-locations. So in order to meet the regulators and the ISO's guidelines, we had to go with the traditional on-premise data centers. And that is why we had to devise a solution. And here is what it looked like. So we had a primary data center, and we had a secondary data center, or you can say the replica or the mirror data center, which is ideally the disaster recovery center. And there was data replication happening between both. So for the user, they would use the primary site as the live endpoint. And in an event of a disaster, they would switch over to the mirror site or the disaster recovery site. So keeping this topology in mind, the disaster recovery center architecture looked like this. So this is the network topology of both the data centers and how they connected with each other. So if you see the first layer, the iNet VLAN, the inter-DC VLAN, this was the VLAN created on the hardware devices. So as I mentioned in the title of the talk, it is actually on bare metal and hardware devices. So this was the first layer, which was the switches that were used in this architecture, and these VLANs were on the hardware VLANs or the virtual LANs created there. So the inter-DC VLAN was meant to connect both the data center, and both of these data center were linked with a direct physical line. So they had connectivity within less than 1 millisecond, which is very important and crucial for data replication to happen. If your TTL is more than 1 millisecond, no data replication can happen. No network-based file share or data share can happen. So that is why we have to make sure that the connectivity is such that the data transfer speed or the TTL is less than 1 millisecond. So we had a similar setup there. So there was a VLAN between the switches between both the data centers, and there was a VLAN for the intranet or for the localized LAN of that data center. So that was the first layer, which was on the hardware switches. The second layer was on, and this is from where the virtualization started over the bare metal, because of course it was not we could not have done the kind of RTO and RPO if we did not introduce automation. And how we use that automation using Terraform, I'll talk about it in the next slide. But this is the layer from where the virtualization devices came into picture. So the first virtualization device that you see here is the NSX Edge. So this is a virtual network appliance provided by VMware. It basically has all the networking features like DHCP, VLANs, firewalls, load balancers, whatever you see in today's modern day cloud. So as a matter of fact, each cloud also work in a similar way where they have created their own virtualized layer on the hardware layer. So that was the layer of for networking, and NSX was the NSX Edge, to be precise, was the appliance or the application which is provided by VMware for virtualized networking. So we use that for our networking within each of these data centers. So we had an NSX Edge which was connected to the inter-DC VLAN, then another NSX Edge on the other data center connected to the inter-DC VLAN. So in that way, they can the systems which are connecting to both networks can still communicate with each other when the rules are set. The third layer was the VLANs, which was meant for the applications and services. So here we had three layers, where one layer was for web application, or to be more accurate, it was the public facing applications. This architecture was a microservices based. We had the Kubernetes cluster, and we had load balancers who would be serving the front end for the the endpoint for the internet facing users. So the NSX VLAN had three layers. One was for the web facing or the public facing services or endpoint, and then comes the app VLAN, where actually the microservices were sitting. So that was the private layer, although they had outgoing internet access, but incoming internet was only restricted from the web VLAN. Then we had the data VLAN, where all the stateful applications, databases, Kafka clusters, etc. were situated. And finally, the fourth layer was the type 1 hypervisor. Because we had bare metals again, we had to use a type 1 hypervisor. We could not use other things. And the reason we use VMware is because it's a licensed software, and it comes in with enterprise support. And because it was a very critical service of financial services, we were handling customer data. We had to ensure that it is not just a one-time setup. Plus, the ISO certification that I mentioned about, this was not a one-time thing. It had to be done every year. This recertification had to be done. So this is a long-term setup that we were doing. So we chose to go with VMware because it had the requirements that fit the bare metal virtualization as well as the support and the features. So the fourth layer you can see at the hypervisor, where actually you can see the virtual machines are sitting. So you have all your VMs over there, and on top of those VMs, you see the clusters and the databases. And then this layer of hypervisor, so the vCenter on both the data center were linked with each other, and the databases sitting on the clusters on VMs on this one would replicate the data in here. So there was live replication going on between both. And when a disaster happened, we would switch over the DNS to the other side. We would do some pre-checks, and then we'll switch over the DNS to the other side, and then the user can continue accessing the application from the second side. And when the disaster recovery commences, we would revert back the same. So this is something. This is the architecture overall process of how we had set up the data center, and how the whole the workflow happened in an event of a disaster. Or to say that we had to mimic this, and we had to record this to get ISO certified. So how did Terraform or infrastructure as code play in, or if I may say, we couldn't have done it within a short span of just 4 months if we did not have infrastructure as code in mind, and if we did not use infrastructure as code as a methodology to operate and orchestrate this entire setup. So how did we do that, and how Terraform played a key role in it? That's what I'm going to be showing in a demo now. So first up, what did we use Terraform for? So Terraform was used as a, first of all, was used as an orchestrator for creating environments on demand. So we had a staging environment for testing the, setup, and then we had production environments, and then eventually we were also planning to have development environments and so on. So since we had the testing environments and production environments, we had to make sure that the environments were similar, at least logically, if not physically in terms of resources, but at least logically the architecture looks same. So we had to create an environment on demand, and Terraform played a role of an orchestrator in this case. So one thing we were sure when we were building it, that if we have to when we have to go with infrastructure as code, we were going with Terraform, and because of certain reasons. Because Terraform maintains, first, one of the features of Terraform is that it maintains state files, which is very important when you are setting up a long-term infrastructure, because the state of the infrastructure, to keep the record of the last state of the infrastructure, is very important, so that you can do changes, upgrades later, because we are not going to destroy the infrastructure every time we do a deployment, because this is going to be very critical and it is on bare metal. So that is why the state the mechanism of storing state files on a backend was very important, and Terraform provided that. And those state files, when copied to an object storage on a cloud, can be version controlled as well, which was very good, because Terraform does not overwrite the state file, but it will just append the state files, and we can see what was different, what was before, what was later. So as an orchestrator, Terraform was provided there was a provider for vSphere for creating the virtual machines. However, Terraform did not provide any provider for NSX Edge, which was our networking appliance. In that scenario, since we were limited, had limited time, and did not have enough time to create a new provider for NSX, so we had to fall back on and the second configuration management tool, which was Ansible, because Ansible provided a ready-made module for NSX. However, it was only for configuring the NSX that we were using Ansible module. The execution still happened with Terraform. So I'm also going to show you how Terraform was used to provision the entire infrastructure using its own provider plus a third-party provider like Ansible. Plus, the fourth thing that we also had was a third-party object storage, because as I mentioned, we had to store these state files to know what, if we even have to do a RAM upgrade, maybe 3 months later, after the launch happened, we had to know that what was earlier, and we had to append it, because we cannot destroy the entire system. So we had to store the state files of the entire system. So for that, we used a third-party object storage, which was an S3 bucket. Although the infrastructure and PII data was all had to be stayed in Indonesia, but the state files were certified and sanitized such that it does not have any sensitive data, so it could be stored in a cloud provider's bucket. So there was a cloud provider which had limited resources at that time in Indonesia, so we could store it in that cloud provider. We did not go with that cloud because it was not certified, and we only had to use it for our backups and other storage. So that's how Terraform was introduced as an orchestrator. The second role that Terraform played here was a provisioner role. So basically, it was the deployer. So the last command that would be run was Terraform apply, and that would call all the other modules, be it Terraform modules for vSphere or be it Ansible modules for NSX. And in this case, while using Terraform as a provisioner, we structured it into a modular infrastructure as code rather than just a bunch of folders and writing infrastructure as code. So it was divided into different categories of modules. So there were base modules, there were provisioner modules, and then there were states, backends, and workspaces with respect to the environment. So that is how the Terraform, as a provisioner, we created modular infrastructure as code. So let us look at how that modular infrastructure as code look like in Terraform. So this is what it looked like. So we had all the modules which were parameterized and created within our module. So you can see here the Ansible NSX. It's a module of it's a, you can say, a playbook using the Ansible module of NSX. Then you have things like for network, for OpenVPN, and for virtual machines. So we have generic modules created for virtual machines, generic modules created for SSH, generic modules created for network. And then when we had to create provisioner, the provisioner would be to create the actual environment. So you can see that there is an administrative or management provisioner, there is a load balancer provisioner, there is a production provisioner, there is a staging provisioner. So each of these are Terraform modules, internally, but they play a different role. The idea is to increase reusability and portability. So because we wanted to have an environment on demand structure, we needed to make the modules as generic as possible so we can create the same kind of environments as many times as possible. So that is why we followed this structure. And as an example, suppose we had to create a VPN server, the vSphere provider, using the vSphere provider, we would just call the TFO VPN and it will be created. Likewise, if we have to create a single load balancer, we would call the TF load balancer, and then which is within the Ansible one, and then it would be created. So that's how the whole structure of our modules and provisional look like. Now, to give a quick overview of how it actually played with Ansible and Terraform that I mentioned earlier. So as I mentioned, Ansible had a pre-built module for NSX. So we decided we would use that because it would save some time. So we use the Ansible module, which gives you the configuration parameter as NSX Edge Firewall. So if it had various roles that we created. So using that module, NSX gives you feature to create firewall rules. Like in case of cloud, you have security group rules. In NSX, you can create firewall rules. You know what is the ingress and what is the egress. So likewise, we created roles for firewall. Say what will be the ingress role for DB, what will be the ingress role for external, the public traffic, what will be the ingress role for HTTP, for SSH, for UDP, and what will be the overall firewall rule. Similarly, we created DHCP rules where we create a DHCP pool for the internal network, which is similar to how you create the VPC pool in case of a cloud. Likewise, we had other configurations. Let's say load balancer was a very important one, where it would actually use the load balancer function of NSX and it would create a load balancer endpoint. And it was very important and very widely used because we had a public facing application and we had microservices. So we had to create multiple load balancer endpoints for different services that were created in Kubernetes. Likewise, and then we had the NAT rules. So NAT is again for allowing outgoing traffic, internet traffic, etc. SNAT and DNAT rules. So these were all the rules that were created using the NSX Ansible for NSX. This product is now deprecated. They have a new product of NSXT, but it was 2-3 years back. So we used that product at that time. So Ansible, if you go to Git, you will find the Ansible and NSX repository, NSXT, so you can have a look at it. So these were the roles that were created in Ansible for creating firewall, DHCP pool, load balancer endpoints, and NAT. Now, when we had to use that in our network, let's say we want to create an app tier or a data tier, like I showed in the VLAN diagram earlier. So let's say we have to create the app tier. We would first call the Ansible repository, which was, we will clone the Ansible module repository. And then there were templates created for firewall rules. And then in app tier, you'd use that template and you would have variables which will map to these, respective IP addresses, internet name, or edge name. So for example, for web, we had DHCP pool and gateway IPs and all of these. So you had all these maps created for each of these network, and then when you had to actually deploy them, let's say we are creating the administrative, or let's say we are creating the staging network. Um, and what we would do is we would just call the network module here, and that will go and call the Ansible code in here. Let's say apt here, it will call this code. So how it will deploy is this way. So this way it will create the environment, and NSX manager, it will call the map, which is basically the IP addresses and all the parameters that we had defined earlier, which was parameterized. So we would use Terraform template to deploy it, and then we would configure all these layers. So likewise, in network, you have firewall rules, and then also the NAT rules, all were created. So although we used an Ansible module, but we were using Terraform to call it. And that way we could actually combine both Terraform and Ansible modules together. So for network, it is, you can see like this. Similarly, you can see the network configuration is like that. And if you have to configure a Kafka cluster, then we were calling the vSphere modules to create the Kafka cluster. And likewise, if we have to create a GitLab runner, or let's say VPN server, so we would actually go ahead and create a VPN server and load balancer, which will call it the load balancer module, and a similar way. So this way, Terraform was used as a provisioner, and that way, what we achieved is that we had modules and we had environment specific provisioner, and Terraform was the orchestrator. And when we had to do the DC DRC drill to record the ISO compliance, we could just use these applications to create the entire infrastructure, and to do the switchover of the data transfer, and to showcase that in an event of a disaster, we can get an entire infrastructure up and running within a time limit of 4 hours. So infrastructure as code played a huge role in this case, because it was on bare metals and on type 1 hypervisors and virtual appliances, and everything was hardware and physical, right? We didn't have the leverage of cloud, the flexibility of cloud services. So using Terraform and infrastructure as a code as a practice, we were able to achieve this whole setup, which was the DCDRC with an RTO of 4 hours and RPO of 15 minutes, which was compliant with ISO 27000. So what we achieved in the end, the final thing is, in short, it was not, it would not be wrong to say that we actually got an on-premise automated environment on demand, or if I would actually like to call it a private cloud or an on-premise cloud, using infrastructure as code. So the infrastructure was built in a fault-aware architecture. It had secure and seamless connectivity. The system was protected not just physically but logically as well, because we have different network, different VLANs for different layers of the application plus different environments. It was automated, modular, and reusable across different environments. If we had to create 5 different environments in down the line, we would be able to create it with the same architecture of ISO compliance. It also had a centralized role, because Terraform within Git, it was used as an orchestrator. So we had a centralized mechanism from where we could control all the parameters, all the values and configurations of the infrastructure. And this also helped enable the scheduled assessment of the disaster recovery. As I mentioned, every year we had to do this ISO compliance. So it was not possible if we had to rebuild the entire infrastructure next year and the year after. So this infrastructure as code actually helped us to take that load of our head, because it is a one time setup and we do not have to do any changes. We only have to probably create a new environment and do a drill, and then we would be done. A very important We also used a framework called the 10 factor infrastructure, which played a key role in designing this entire architecture that I showed earlier, is actually a framework to build a security, scalability, and sustainability as a first class principle of infrastructure as code. So it provides 10 factors which are needed for your infrastructure for these features. So it had network with seamless and secure connectivity, system with stable and scalable setup. As I mentioned, it had Kubernetes cluster, so we could scale it out. Again, I did not have much time to explain how we did in Kubernetes, because we were using virtualization Kubernetes way, using Kubespray. So that was also used, again, a self-managed Kubernetes cluster. Then we had storage, which was a separate hardware device again, which was launched into the VM. Then we had identity management, and I had showed in the demo that we had a VPN module, which was essentially using Open VPN software, which would give role-based access control on specific environments. So not everybody will have access to production, only specific people, and that we controlled using the VPN. And then we had securities, like we saw the firewall rules, the NAT rules, the different subnetting, and the VPN rules, the load balancers were all on SSL. So that was part of security. Then we had logging and monitoring. We had the standalone, self-managed logging systems and monitoring system for this entire thing. And as we described in this session, it was an HA setup, although it was not an active HA, it was an active passive HA, but there was still HA available. In an event of a disaster, we could still fall back and we could meet the RTO and RPO and SLA that we had defined. Of course, it had the disaster recovery center and environment on demand, which was provided by using Terraform as an orchestrator and infrastructure as code. So this is the 10 factor infrastructure framework that we utilized in designing the architecture that you have seen. If you want to know more about this project, we do not have much time, I guess. And if you want to know more, so you can connect with me. I would be happy to share more in details on how each of these components was devised. This is my website link, and this is my podcast link, where I have actually published 10 episodes on this 10 factor infrastructure, and I go much in-depth analysis of how this was done, and there are much more details in there. And of course, you can follow me on social media, on LinkedIn, and I guess we can proceed with the next session and with the questionnaire. So thank you so much for providing the opportunity and for being in this talk.
Thanks, Kamalika. Great presentation. It is surprising, even after so many years that Terraform has been used, that uh, it really kind of like accelerates your adoption uh, to moving assets around. I think if you are in the business of SaaS and you are looking to establish the RTOs and RPOs, then I think this is an excellent resource for you to look at. Please connect with Kamalika. I think she would have great insights on how you can start your journey on this. And with that, our next speaker is from Oslo, Norway. His name is Ashish Singh Begel. He's a digital enthusiast and solution architect, and he's going to talk about deploying infrastructure as code on Azure using GitHub code spaces and Terraform Cloud. So there's a lot of love for Terraform in the community. So it's great to see our next talk. Over to Ashish.
Hello everyone, welcome to HashiTalks India. My name is Ashish and today I will talk about deploying infrastructure as code on Azure using GitHub Codespaces and Terraform Cloud. A little introduction about me. My name is Ashish. I work as solutions architect. I'm mostly working on automation, DevOps processes, and we are trying to solve complex business problems. Now let's talk about the challenges which we face whenever we are working on a Terraform project. One challenge is non-standardized dev environment. All of us use different types of machines. Some of us use Mac, some of us use Linux, some of us use Windows, and we install and configure different tools, different extensions which help us in development. This sometimes causes some problems. Another problem which we need to solve whenever we are working in Terraform is state file management. We have to ensure that we have a remote backend configured for state files. State files are also sensitive, so we have to ensure that it is protected, right? Another challenge in this Terraform projects is access control. We have to ensure that we follow principle of least privilege, both for Terraform as well as users accessing Terraform. So how can we solve this? So we will try to solve this problem using GitHub Codespaces, Terraform Cloud and Azure. Solution is that we will try to create a personalized Terraform development environment which anyone can access instantly, anytime, anywhere in any machine. And this cloud development environment will talk to Terraform Cloud for remote operations, and Terraform Cloud will also help us in state management. We will use Azure's service principal concept to create role-based access control for Terraform. How can we achieve this? There are three simple steps. Step 1, we will create a service principal in Azure. Step 2, we will configure Terraform Cloud to use the Azure service principal, and we will also configure Terraform Cloud as a remote backend for our state file. Finally, we will create GitHub Codespaces, and using GitHub Codespaces, we will develop and deploy our infrastructure on Azure. So let's see how we can do this. So first thing what we want to do is we want to create a service principal in Azure. And as you can see, I am already inside Azure portal, and I will click on this Cloud Shell button. So this will give me a terminal to work with Azure. And what I will do, I will use Azure CLI command to create a service principal in Azure. To do this, first thing we need to ensure that we are using correct subscription. So first command I will use is to list all the subscriptions which are available to me. I will use EZ account list, and as you can see, this command is giving me the information that there is currently only one subscription which is available to me. So I will copy the subscription ID, and next thing what you want to do, let's say if you have multiple subscription, you would want to set that subscription. So you can use EZ account set, and then you can give subscription ID. This will set the subscription in your current context. Perfect. Now let's just check whether we have correct subscription. So we can use as EZ account show, and EZ account will show you the current active subscription in Azure CLI. Perfect. Now we are sure that we are using correct subscription. So now we can create a service principal in Azure. To create a service principal, we will use AZADSP create for RBAC. Now this create for RBAC is a very special command, because this will not only create a service principal identity for us, it will also create a role assignment for that identity. So to create, first information what we want to provide to this command is we want to provide a name. And since I'm creating this Terraform identity for Terraform Cloud, I will give it a name Terraform Cloud. And next what I want to do is I want to provide what role I want to provide to this identity. So Azure has some default built-in roles. I will provide contributor role, because yeah, because contributor role is something which Terraform Cloud will need to spin up resources. Perfect. And next thing is we want to specify scope, that this role should have a scope. So the scope is our subscription, where you inside which we want to create resources. So I will use subscriptions, and I will provide the subscription ID. Perfect. And this is all you need. This single command will do the job for us. And as you can see, this is giving us an output that it has created contributor role assignment for our subscription. And another important point, that this output includes credentials. So the output which is available to us, it contains a password, and we have to make sure that we do not include this credential in our code. So we have to protect this password. All right, perfect. So now our Azure service principal is available. So I want to show you one more thing. I can show you that how this service principal looks in Azure. So I can navigate to Azure portal and I can click on subscriptions. You can also search for subscription in the search bar if it is not visible to you in the home screen. And I can go to my subscription ASB test 001 and I can click on access control IAM, and then I will check the role assignments. And inside role assignments, I should see the Terraform Cloud role which I have created. So as you can see, this Azure CLI command has created the service principal for us and has assigned it a contributor role in our subscription. So this looks perfect. Now we can move to step 2. So step 2 for us is to configure Terraform Cloud. And to configure Terraform Cloud, I will navigate to app.terraform.io, and I'm already logged in using my Terraform account. And as you can see, currently I don't have any organization created. So what I will do, since if you are accessing Terraform Cloud for the first time, you will see a screen like this. So you would want to select the second option here, start from scratch, and now Terraform will ask you to create a new organization. So I will create a new organization named HashiTalks India, and I will click on create organization. And perfect. So now HashiTalks India is one organization which is available to me. So second thing is which I want to configure is I want to go to settings, and inside settings I want to search for variable sets, and I will create a variable set here because we want to ensure that our organization can authenticate to Azure. So this variable set, I will name it as Azure credentials. And what I will do, I will select that apply this variable set to all workspaces in my organization. Perfect. And now I would want to assign, create some variables. So first variable, which environment variable, we have to make sure that the variable category which we are selecting is environment variable. So first environment variable I want to create is known as Azure subscription ID. Okay. And this Azure subscription ID, we already have that available here. So this is our subscription ID which we have selected. So we will provide this information here. Second Azure variable, second variable which we want to create is Azure ARM tenant ID, and this is the tenant ID which we have got the tenant ID in the output of our command. So I will provide this information here. Perfect. Third thing which we want to provide is our client ID. So client ID is nothing but app ID in the output of our command. So this is the app ID which I want to provide in Terraform Cloud, and I will paste this value. And finally we want to configure client secret, and client secret is nothing but password which is available here in this output. And there you go. Now second important point, we have to ensure that we mark this password as sensitive. So this will ensure that sensitive variables are never shown in the UI or API. Okay, so it is kind of important to mark this password as sensitive because we don't want the secret to be visible in user interface. Perfect. Now I have saved it, so all four variables which I want are available now in my Terraform cloud organization, and I will click on create variable set. Perfect. So Azure credentials variable set is finally available. Next thing what I want to do is I want to click on my user icon and I want to go to user settings, and inside this user setting what I will do, I will go to tokens and I will create this API token. So this API token is nothing but a token which I will use to authenticate to Terraform Cloud. Okay, and I want this token for my code space. So I will give a description that I want to create a token for code space. I will create this API token and I will copy this value. Perfect. So second part of our setup is complete. We have created an API token for our user in Terraform. Perfect. So let's go back to our organization HashiTalks India. Perfect. So this is all we want to do in yeah Terraform Cloud. So finally we want to set up our GitHub and we want to configure GitHub code spaces. So to do that I will navigate to my GitHub account, And in GitHub account, first thing what I want to do is I want to go to settings, and inside this settings I will have this option called code spaces, and inside this code spaces we have this section called code space secrets. And this is important because I will create a new secret. I will name this secret as tf token underscore app underscore terraform.io, and I will paste my user token which I have created in Terraform. So what will happen actually is that Terraform CLI will use this environment variable. So this code space secret will be mapped to all the code spaces we will create, and we can select a repository. So I will select the repository where I want to map this secret, and this secret will be available to us in all the code spaces we will create for this repository. And Terraform CLI will use this variable to authenticate to Terraform Cloud. Perfect. So I will click on add secrets, and our TF token app terraform underscore io code space secret is now available. Perfect. Let's navigate back to our repositories, and now I want to click on this demo code space terraform because this is the repository where I already have my terraform code. So as you can see, it contains a terraform folder and it contains all my terraform files. Perfect. So this is the repository where we will create development container. We will create cloud development environment. So to create a cloud development environment using code spaces, what you have to do is you have to click on the code here, and as you can see there are two tabs available, local and code spaces. So we want to use code spaces right now. So we will click on this button, create code space on main. And as soon as we do this, what GitHub will do, GitHub will try to spin up a code space for us, and it will be a default image, default template which is available to us. And default template is not good for us because we want Terraform CLI and some other softwares and some other extensions available to us to work in our repository, right? But yeah, we will create that configuration once we have this default template available. So as you can see now, we have our code space available in browser. In the bottom corner you can see it says code spaces. I will zoom in a bit, and as you can see in the terminal output, welcome to code spaces, it says, and it says that you are on default image. So the problem is, if I will do terraform dash dash version, we don't have terraform available here. Okay, so yeah, so what we will try to do, we will try to create our own code space template. Okay, so to do that, press on F1, and F1 will open a command palette for you, and search for add dev container configuration files. And as soon as you search for it, you will see that there is this option available which is telling us that you can add dev container configuration files, and this is exactly what we want to do. So I will select this option, and now this is telling me all the templates which are available to me. Okay, so there are predefined, pre-configured templates which you can use. So let's say if you are working on Python, you can select Python images, and let's say if you want to, if you work on Node.js, you can select Node.js. But for this demo I need to use Terraform. So to do that, what I will do, I will select Ubuntu base image, and I will select the default version as Jammy. And next I want to install Terraform. So this is where additional features comes in handy. So additional features is nothing but pre-configured scripts which CodeSpaces provides you. Okay, and using these pre-configured scripts I can install whatever software I want. So let's say I want Terraform, so I will search for Terraform, and as you can see there are many Terraform scripts available. I will choose this dev containers script because this is being maintained by dev containers. So I will select this and I will click on OK. As soon as I click on OK, what code spaces will do, it will create a folder and it will create a file, dev container.json file inside my repository. And the interesting fact is that this JSON file is nothing but a template for my development environment in cloud. And as you can see that this template has all the information that I'm using this Ubuntu base image jamming, and I have installed this Terraform dev containers feature. Perfect. Now since this template is available, I what I want to do, I want to rebuild my image. So I will press F1 and I will do search for rebuild and I will select the option rebuild container. So using this option, what code spaces will try to do, that it it knows that we have a template file available in the repository. So this time code spaces will use that template file to create a development environment for us. And this is very cool. So why this is cool? Because we can customize that template file in the way we can. So we can install whatever softwares we want. We can configure that template file to use whatever extensions we want to configure in our development environment. So yeah, this is why this code spaces is very handy as a cloud development environment. And as you can see, everything is accessible and via browser in in my machine. And since this template is available in my repository, any team member who wants to contribute to this project can use this template to spin up a development environment for for himself. Perfect. So as we can see now, it code spaces is telling that we are on a custom image defined in our dev container.json file. Perfect. This is exactly what we wanted. So let's check whether we have Terraform available. So I will do Terraform dash dash version. Oh, Terraform dash dash version. Perfect. So as you can see, now we are getting the output that Terraform version 1.3.7 is available to us thanks to this features available for code spaces. Perfect. Since now we have Terraform version available, and let's check environment variables because we have mapped our code space secrets. So as you can see, this is the secret which GitHub code space secret which we have added in our settings, right? And as we can see, our secret is automatically mapped as environment variable in our container. So we are good to authenticate to Terraform Cloud. Perfect. Next thing what I want to show you is that we need to ensure that we have this inside this terraform.tf file. I have this Terraform block, and in this Terraform block we have to ensure that we have this cloud module available, cloud section available. And in this cloud section we have to ensure that we are using correct organization and whatever organization we have created. So as you can see, we have created HashiTalks India organization. My cloud section here has the correct value set, and workspaces will be created automatically when I will do Terraform in it. So good, this is looking good. So what I want to do now is I want to initialize this Terraform cloud. So what I will do, I will run Terraform in it, and as soon as okay, perfect. So Terraform in it, it will not, I need to be in correct directory, right? So all my Terraform files are inside Terraform directory. So I will cd into it, and there you go. And I can check that yes, this is the folder where all my files are available, Terraform templates are available. So what I will do now, I will run Terraform init command, and as you can see in the output I am getting that this is CLI is initializing Terraform Cloud. Because of this configuration, Terraform CLI knows that it needs to configure cloud. And let's go back to our workspace and let's refresh this workspace. And as you can see, now Terraform has created HashiTalks demo workspace for us. Let's just click here, and perfect. So since HashiTalks demo workspace is now available, we can now spin up resources. So let's spin up resources using Terraform apply. So I will run Terraform apply dash dash auto approve. Perfect. So this Terraform apply command is actually running on Terraform Cloud. So we have given the command in the code space, but since we are authenticated to Terraform Cloud and our workspace is configured, this Terraform apply command is actually running on Terraform Cloud. And as you can see in this overview for our workspace, HashiTalks demo workspace, we can see that a run is currently running. And we can click on see details, and as we can see that there is a plan running, and we can see the output of this plan in this Terraform Cloud user interface, as well as we can see this output on our code space container as well in the CLI as well. Looking cool. Perfect. So as we can see that now Terraform is planning to add 10 resources for my Azure subscription. And we can navigate to our Azure subscription, we can navigate to resource groups, and we will see that after some time our resources will be available on Azure. So let's check. There you go. Yeah. So we will wait for Azure to spin up our infrastructure. Perfect. There you go. So RG Honest Fox, this resource group is now available, and we can see that Terraform is now creating our infrastructure in this side this resource group as per the information available in my Terraform infrastructure as code files. So we will wait for this to finish, and all the output apply output everything is we can see this information in our Terraform cloud, as well as this information will be streamed on your terminal as well. How cool is this? And this is exactly what we wanted to configure. We wanted to have a cloud development environment. We wanted to have a tools which we wanted to be installed in our cloud development environment. And the greatest thing is that this is accessible to me anytime, anywhere. Perfect. So as we can see that apply is completed, resources are added. We can go back and we can check, refresh this page, and as we can see there our virtual network, public IP, NIC, everything is available. I can go to this RHL virtual machine, I can check for public IP, and I can see that this public IP address matches exactly the output which is available here. So we are now sure that the virtual machine which is available here in this Azure is created by Terraform. This looks perfect. So next thing what we want to do is that we want to check in this template in our repository. So I will move out of this Terraform folder, and I will do git add dot, and I will check git status. There you go, my dev container.json template for my cloud development environment. It's ready for check-in. So I will do git commit message, and I will give a message add dev container config files. Perfect. And there you go, commit is available, and I will do git push. Perfect. So now I have created a commit from my cloud development environment, and this dev container.json is the template which I was using for my cloud development environment, and this is now available in my repository. Perfect. So let's go back to our repository. Let's refresh this page, and as you can see that this dev container folder is available, our template is available, and now anyone who wants to help me in my project can simply come here, click on code, create a code space, and GitHub will create a code space based on the template file available in my repository. How cool is that? This is a standard template, and we can customize this template in any way we want, right? So yeah, so let's say you want to install additional extensions, right? You want to install additional softwares. You can even write a Docker file instead of using Ubuntu base image. You can create a Docker file, and you can use your own base image, and you can use your own commands to install whatever softwares you want to set up. All right, so I think this is all I wanted to show you, that how you can integrate GitHub code spaces, Terraform Cloud to spin up resources on Azure. And this is one of the coolest technologies which is available today. Perfect. So as we can see that this output is telling me that you are on code spaces and you have image available as per dev container.json file. So now if I will try to select Terraform dash dash version, it should already be available, and there you go. As you can see, Terraform version 1.3.7 is already available, because it is specified in my template that I want Terraform in my cloud development environment. How cool is that? There's one more thing which I want to show you in our Terraform workspace, which we have created from our GitHub code spaces, is that we have our state file currently being managed by Terraform Cloud. So the state file is now available in Terraform Cloud, and as you can see, we can check the state file by clicking on the states menu here. And currently we can see that all the infrastructure which was created on Azure, it is available, the information is available in this state file. So yeah, so this is another beautiful feature about Terraform Cloud, that it will manage your state files, and multiple team members can work on the same state files which is being managed by Terraform Cloud. Perfect. So let's check out what we have done so far. We have used GitHub Codespaces to create cloud development environment. Using this cloud development environment, we are triggering runs on Terraform Cloud, and we are using user specific API key to trigger these runs. Terraform Cloud is then provisioning infrastructure on Azure, and Terraform Cloud is using service principle which we have created specifically for Terraform Cloud. Once infrastructure is up on Azure, Terraform Cloud is also helping us in state file management. How cool is this? Here are some references which I have used to prepare this demo. So if you are interested in this setup, please feel free to check it out. Finally, I want you to have some key takeaways from this talk. First is GitHub Codespaces enables personalized cloud development environment. You can use Terraform Cloud for CLI driven workflow and state management. You can also use service principle for role based access control. Finally, last but not the least, please get in touch. You can follow me on GitHub, you can follow me on Twitter. Please feel free to send me a connection request on LinkedIn. Techhackswithash.com is my website. You can find all these links here. And do not forget to check out my YouTube channel as well. Finally, I want you to check out my GitHub repository. This repository has all the instructions about the demo which I have performed today, and you can follow it to create your own CodeSpace Terraform environment to provision infrastructure on Azure. Finally, all I want to say is thank you so much for attending my talk, and please enjoy rest of upcoming HashiTalk sessions.
How cool was that? That was pretty cool. I Ashish, I specifically loved how you took a practitioner approach to this whole talk. I myself was a Terraform practitioner before I even joined HashiCorp, and specifically loved Terraform Cloud. Once you go Terraform Cloud, you don't look back. So anyone who's tried to bring three of these platforms and tools together know how hard it is to demonstrate all that. So really phenomenal job. I also loved how you touched on all the security aspects and single role-based access and securing your credentials. Phenomenal job. Our talks get interesting. Oh, by the way, using the code relevant to HashiTalk India, nice job. Our talks are getting better, and so staying with sort of the Microsoft theme. The next one is going to be about Windows-based microservices. This one also is very close to my heart. Nomad is one of those very cool platforms, great scheduler, lightweight, and Abhishek Dubey is here to talk to us about it. He's a technology enthusiast with over 5+ years of experience with latest DevOps tools and practices. He works as a DevOps consultant. He's also contributed to a lot of open source projects, which is awesome. So without further ado, Abhishek, please take us away.
Hari, thank you for that warm introduction. I hope my screen is visible. I'm sharing my slides. Yeah. So guys, hi everyone. So today we are going to talk about managing the different types of window microservices using Nomad. I know people have a different perception about the orchestration services. A lot of people use Kubernetes and all, but here I want to give a different view of Nomad, which I get to learn about while doing an interesting project. So again, my introduction has been already done by Hari. So I'm a DevOps consultant working with Opsi Solution. I'm a technology enthusiast. And I'm an open source contributor as well. I do contribution in HashiCorp projects and the projects like Kubernetes, Prometheus. So I'm one of the developers on those projects as well. So that's it about me. Yeah. Here, before going to the main part of the Nomad orchestration using the Windows microservices, here I want to give a little walkthrough of the Nomad as an orchestration engine. So I guess a lot of people already have the context around it, but I just want to give a little bit of glimpse of it. So basically, HashiCorp Nomad is an orchestration platform which can manage a microservices environment and which can manage a complex microservices environments very easily. And one of the very good benefit of using the Nomad is that you are not restricted to use only containerized applications. So while other orchestrators are limited to the using the containerized applications and all, you can run non-containerized applications as well using the Nomad. It can run used for the running the deployments. It can be used for running the batch jobs and many other purposes as well. Also, Nomad comes with another beautiful product of HashiCorp, which is called Consul. So you can integrate Nomad and Consul, and through that you can achieve the service mesh and the other features of it. Other than that, Nomad is a cross-platform. Since it's written in Golang and designed in Golang, it can support the different platforms as well. So, for example, you want it run on a Mac OS system, you want to run it on a Windows system, you want to run it on a Linux system, you don't have to worry about it. You can run it very easily. Now, next question is that when we already have a lot of orchestrators available in the market, why do we need Nomad? So one thing is that I love about the technologies which enables the plugin mechanism, where we have our own custom plugin and we can club it to the main system and we can do anything about it. So for example, that is one phase of philosophy on Nomad is based on. So basically it is not restricted to running the microservices on the container basis. For example, you would directly want to run the Java applications. You can integrate the Java plugin with the Nomad and you can run the Java application. And let's say you want to do the virtual machine management using the Firecracker, you can integrate that. And other than that, Nomad provides an extension point in terms of the custom plugins where you can write your own custom plugin, which we have done so far. And you can integrate that custom plugin to the Nomad, and then you can leverage the functionalities of the Nomad. So that's what we did with the our project, which we are going to explain in the further slides. Now, again, another reason of using the Nomad is that while the other orchestrator have this little bit dependency on the Linux operating system and they work great with the Linux operating system, but for the other operating system, they are still in the development phase and they are evolving. But the one thing is the Nomad is that, again, we have explained that it's a cross-platform binary which can run on any kind of system. So for example, here, if you see that our Nomad and Consul server is running on the Linux platforms, but you can run the Nomad clients on the Windows platform as well. Since it's a OS independent project, so you can install it on the any kind of operating system, any kind of architecture. It's not only always restricted to AMD kind of architecture. You can run it on ARM based system. You can run it on over a Raspberry Pi system as well. So that is also a possibility which we have with the Nomad. So that's a really cool thing about the Nomad. And these are some other reasons which are already part of the a basic orchestrator functionality, that Nomad supports the auto scaling. And it not only supports the auto scaling, it also supports the integration with the different metric system. For example, you can integrate your Nomad with some other monitoring system. For example, you can integrate it with the Datadog, we can integrate it with the Prometheus, and from the metrics calculation, you can do the auto scaling. So for example, whatever the metrics we are getting on the basis of threshold, I want to do the auto scaling, I can easily do the auto scaling using the Nomad with the other projects. And the failover part is also there. So one thing with the orchestration engine is that once my application is ready and running, then only it should serve the request. And if it is not ready, it should not serve the request. So that's the bare minimum functionality which orchestration engine should support, and that is already supported by the Nomad. So let's say if I have a set of microservices running, and those microservices have different replicas, so let's say 5 or 10 replicas of those microservices, and on the basis of that, basically in between those 5 to 10 replicas, 2 replicas are not responding. So the orchestration engine will not send any kind of incoming request to those systems. It will send the request only to the healthy system. So that is the failover is also the part of the Nomad orchestration engine. Then metrics monitoring. So basically Nomad has a it's a direct instrumented project with the Prometheus. So basically, when we say directly instrumented services, in that case, you don't even have to install the agent. For example, I directly want to monitor the Nomad and let's say console to the Prometheus. I don't have to install any kind of agent. I just have to enable some specific configuration, and after that, I'll be able to monitor the complete platform on the Prometheus like system. And let's say if we don't want to use Prometheus and we want to use some other metrics monitoring system, in that case as well, we are not restricted by the functionality. You have different agent available for the Nomad monitoring, which you can install, and you can monitor your complete Nomad cluster. For example, you can monitor it over the Datadog, Dynatrace, other monitoring system. Then service discovery. So service discovery is not technically the part of the Nomad service. Nomad directly does not support the service discovery. You have to integrate the HashiCorp product, which is called Console, which is specially built for the service mesh and the service discovery concept. So basically, you can integrate the Console with the Nomad, and through that you can achieve the service discovery between your microservices inside the Nomad cluster. And then nowadays, this is a very popular concept of the service mesh, where we have to create end-to-end encryption connection between two services. So basically, that is also one of the thing which Nomad is supporting with the help of Console. And with the Console Connect, we can install the Envoy proxy as a sidecar, and that can help the microservices talk to each other in a secure fashion. So service mesh and the service observability is also one of the thing which is supported by the Nomad large widely on the complete cluster. Now, this is the main agenda which we wanted to talk on. So basically, the major problem statement that we have while working on something, that we had a project called a traveling site. And on that traveling site, the thing was that they were running the major applications on the .NET applications. And it was not .NET Core 5, so that was they were managing over the Kubernetes and other platform, but they had a large chunk of applications on the .NET applications, and those applications were running on the static Windows instances. But the challenges with the static Windows instances were a lot. First thing, that we did not have the scaling, because those were static instances, so scaling and downscaling is something which was not part of the scope. The failover, whatever the thing which we have mentioned on the previous slide, that was something which we were not able to do on the Windows based microservices. And since they were using Kubernetes and orchestration engine, they did not give a thought about some other thing. But while working on the Nomad, I came across this amazing concept of the plugins. And so what exactly we did as a solution, we identified a plugin which is supporting the IES drivers of the Windows, which is called the Nomad Driver IES, which is created by a Roblox organization. And we forked that project, and we did the further development on it. So what exactly Nomad supports, that you can create any kind of custom plugin and you can integrate it with the Nomad system. And once you integrate it with the Nomad system, in that case, you can leverage the Nomad functionalities with those plugins. So this is what we wanted to do. So what we did, we took this Windows IES plugin, which was open source, we customized it, and we integrated with the Nomad system, so that we can take the leverage of Nomad system. And after that, whatever the .NET based applications we had, we were able to manage those .NET applications using the Nomad platform very easily. Now, this was the solution architecture we had while working on this particular project, that over the period of time, we completely migrated to the orchestration engine as Nomad, because here we did not have the complexity of managing the two different orchestration engines. A single orchestration engine was able to support our both functionalities, where we have to run some Dockerized applications, and another use case was running some custom applications of the IS sites, which is based on the .NET based application. So what exactly we did, we created the pool of 3 Nomad leaders, and on the basis of that, we integrated the console servers. And after that, we added the agent to that Nomad leader pool. Now, in that case, we have a Linux follower, we have a Windows follower, and we divided it. So basically, whatever the applications which were running on the Docker engine, we were targeting for the Linux follower. So all the Dockerized applications were running on the Linux follower pool. Then whatever the applications, we have the .NET based applications, and we wanted to run it over the Windows platform, we installed our custom plugin on those nodes, and we targeted all the Windows based applications on that particular node pool. In that case, a single orchestration engine was able to support our both use cases. We were able to run the .NET based applications, which is completely restricted to the Windows, and we were able to run the Dockerized applications using the Linux followers as well. So that is the solution architecture we came upon on using the Nomad orchestration engine. Now, the question is that how did we able to enable that custom plugin? So basically, Nomad provides you the some set of configuration where you have this functionality. You can enable your own custom plugin. So basically, you see that I have highlighted this particular area where I can define that this is my plugin directory and where I can store my plugin. And once we have stored that plugin, the Nomad will automatically pick it. And after that, whenever you have installed the plugin, you have to enable it, because by default the plugins are disabled in the Nomad. And whenever you are integrating a custom plugin, or let's say the existing plugin which is supported by the Nomad, you have to enable it. So here we have enabled the plugin called WinIS, which means Windows IS system, and then we have enabled the configurations. And once we have done this, that's it. Our Nomad platform is able to run the .NET based applications on the IS sites very easily and without any challenges. Now, this is something which is interesting here. So basically, we have the job and task, and on the basis of this job and task, we have like a definition of the job and task of the IES configuration. So basically, if you see here, we have created our own custom block inside the Nomad, which is called this config block. So this is something which we have as a generic block inside the Nomad, where you have to define the name of the job, you have to define the data center, then you have to define the type of service, and you define the count. This is something which is a generic concept of Nomad and supported in all plugins. And again, this is also something task set which is enabled, which is restricted to this custom plugin only. So basically, in the task, you have to define the driver which you are using. So for example, if I'm running a Docker based application, I say that in the driver I want to use Docker, and then I define the configurations related to Docker. But here I'm using the IS as a custom plugin. So I say that this is my driver and this is my artifact. So artifact is something where we have to provide that the application which we want to deploy, and I'm providing the driver. And once I have defined this, there's a configuration block. Now this configuration block is something which will always update on the basis of driver. So let's say in my case, the driver is Windows IES. And according to that, I have to define my configuration related to IS configuration, where we have defined the path where my application will be running. The application pool identity. This is something the IS property which we have to define, that I want to use the network service, I want to use some other IS property. And let's say the bindings. What should be your bindings? The type of bindings. For example, the application is running in the HTTP form, or is it running on the TCP form, and the label of the port, something like that. And let's say if the driver was Docker, we have updated the configuration. We have to update the configuration related to the Docker part. But since we are running the custom plugin, WinIS, accordingly, we have defined the configuration here. And that's it. Once we have defined the task definition of the complete job of the Nomad task, we will have a picture like this. So basically, the allocation will be starting running on the Nomad cluster, where you see that my two IIS applications are running here, and those are being registered on the console server. So if we want to identify these things, we can easily see that whatever the services that being are created on the Nomad, that are being also registered on the console as well. And you can see that this is registered via Nomad is already highlighted here. So basically, this is how a single platform we use to manage all type of application, whether it's a Linux-based microservices, whether it's a Windows-based microservices, we were able to manage very easily on the Nomad platform. Now, let's say if you want to simulate this complete environment, what exactly we have done. Let me share my again another tab of complete screen. Let me share it. Yeah. I think you will be able to see my entire screen now. On the entire screen, now you can see this is a project which we have prepared, which we already have mentioned on the particularly slides as well. On the slides as well, I have shared the link of it. So this is the Nomad driver IES plugin, which have the complete simulation of it. So basically, it's a Go plugin which can be compiled and stored inside the client machine, and then you can run it. So basically, to simulate this particular project, I have created a Vagrant project. So basically, this Vagrant project is something which can be used to run the complete application. So basically, you don't have to do anything. There is a Vagrant file present here, which can do the complete simulation of the project, where you want to run a Nomad server, a Nomad client, a console server, and it can install the plugin as well, and it can run your application as well. So basically, this Vagrant is also one of the HashiCorp project which we have used. It will use a Windows image, and on the basis of the Windows image, it will install all the necessary thing For example, if I go to the scripts part, I'll explain it here. It is using a PowerShell script where it will install the Git, Golang, console, Nomad, and after that it will creating the services and all. So once this has been created, your Nomad and console service will be running on the same system. And then once it is ready, you have the example folder here, and inside the example folder you have the IAS test nomad where the complete example is available, where you can define this complete data centers type, count, and the restart details. Then you have the drive task. In the task you have defined the driver equals to win IAS, and then we have defined the source artifact. So this is a sample.net based application project which I have already uploaded so that people can test it. And then in the config path we are defining the IAS related configuration that I want to use. Netcore app is the application name, and this is the task directory. It is available here. And then we have the app pool identity. We are defining the network service bindings, and this was something which was not supported by default inside the this IS driver plugin. That's why we have forked in and we added this customization. So basically now it is supporting the resources block as well. So CPU memory can also be restricted for a process. So basically it's nothing like that. You can run the service and that service can choke up complete CPU and memory of a system. You can always restrict that process in terms of CPU memory. So that is also one of the functionality which we have added here. Then we have the service block, which is registering all these services to the console system. So if you want to try this complete simulation, please go through this project. Please try to simulate it. And let's say if you face any issues, you can open the GitHub issues and I'll try to fix those things. But yeah, I have already tested this project multiple times. I use it for my development. So I really doubt how it will show any issues. But let's say if you want to see how exactly we can build this, there's a documentation available in the form of particularly markdown format, the readme format. So in the readme we have defined how you can build the plugin, how you can configure it, and how you can run your job. So all the things are in place in the terms of readme file. So do check out this project and let us know that if you face any issues and all. Now again, I would like to do the summarize of the complete things which we have explained till now. So basically a lot of people have this perception that when we talk about the orchestration, they think about Kubernetes is the only orchestration engine available right now in the market, which is super successful and can run all kind of microservices. But there are few things for which we can always leverage orchestration in systems like Nomad. So for example, here we have a custom plugin requirement where we have the Windows based applications and we cannot run it on the Kubernetes. The reason was that the Kubernetes is not that much stable on the Windows side, and we identified that Nomad is something which is supported on all type of platform, and we can leverage that. So we decided to go with the custom plugin. We integrated that custom plugin inside the Nomad, and we were able to run all the Windows-based microservices, which we were not able to do that. And once we integrated this system, we have the functionalities of auto scaling, failover, and all those things of a basic orchestration engine inside our applications. And right now we are running around 250 microservices over this Nomad platform on the Windows part, particularly. The Linux is different, but Windows microservices, we are running around 250 microservices using this particular plugin and the Nomad platform. So that is one of the things which we talk about. So basically, you can always look for a better alternative rather than relying on the popular solution, which can provide you the more suitable functionalities related to your system. So that is something which we have done with the Nomad. So yeah, that's it from my side. If you guys have any questions, please let us know.
Excellent presentation, Abhishek. I really enjoyed how you went from simpler footprint to something which was production setup. So I think one thing that you called out is the ecosystem integration bit, which is particularly talking about the plugin ecosystem. And I think that's where Nomad and all of the HashiCorp products usually shine, because I think you can even throw Vault into the speech picture and you can get like dynamic creds, right? So excellent. This is really interesting. I really uh, encourage everyone to look through this, and hopefully hopefully you can connect with Abhishek if you have questions on this line. I definitely thought for a moment that this tapped into the principles of HashiCorp, which is like build simpler, modular, composable structures, and it also taps into the one of the towers, which is one of the principles, which is like beauty works best, right? So excellent stuff. Next we have actually, before the next speaker, I wanted to share that if you are tuning in right now, remember that we'll be sharing some of these, like all of these talks on YouTube in coming days. So you can definitely catch up later. And our next speaker is Basil, who is the co-founder of CoIT.io. He is a corporate trainer. He has over 15 years of IT experience and an open source enthusiast. He has spoken at many conferences, I think the latest being the US Conf in 2022. And he'll be walking us through infrastructure and configuration management as code. Over to you, Basil.
Hi there, my name is Basil and I'm co-founder at Co-IT Technologies. And I spend a lot of my time taking training on DevSecOps and cloud native technologies. And the company that I co-founded, Co-IT Technologies, we focus on providing custom training solutions to the corporates based on demand from them. So that's what we do. You can reach out to me on my contact information given inside the page. So let's get started with our today's topic. So Terraform is great. You already know that many people, it has become the de facto standard for maintaining and managing the infrastructure in most of the companies, right? So you, in the cloud, you can provision your resources, the virtual machines or networks or storage devices, databases, or anything that you need can be maintained and managed using as code using Terraform, right? And that's great. And it's not just Terraform that you would be using in your company. You would be using a lot of other tools to maintain and manage this infrastructure. For example, you might need the deployment tools to take the latest applications to your infrastructure settings. And you might be using some config management tool like Ansible that would actually make sure that every infrastructure component look exactly how they are supposed to look like, so that they are ready to run your applications. And you might be using monitoring tools to maintain and monitor your applications and the infrastructure. So there will be a whole bunch of tools and technologies that your company would be using. And the whole purpose of maintaining and managing your infrastructure is that you want to run your applications, right? I mean, that's what you want to do, and you want to run those applications in a reliable way. So the problem what we are going to face here is that we are talking about a lot of resources in the cloud, hundreds of machines or thousands of them, and hundreds of network devices, storage devices, databases, and things like that. And you have too many applications that need to run in those devices, right? Some of the machines are supposed to run your production applications, while some other machines are used for running some test and dev applications. And then some of those machines are supposed to run some web-based application. Some of them are supposed to run some of your backend microservices. And then, right, so every machines will have its own roles and things like that. So different tools that your company uses to manage those applications, they need to have a knowledge on what your infrastructure is, what are the different resources that are part of your infrastructure, and how they should be configured, right? I mean, if you are running using a pipeline to build and deploy your applications, this tool need to know which application needs to be deployed into which machines, right? So there are a lot of information that that all your tools should be aware of, right? What the machine roles are and which environment they belong to and stuff like that. So we are going to talk about how you can use Terraform to create proper identifiers for every resources that you create in the cloud. Then other tools can automatically detect those identifiers to understand what those machines are, right? So let's get started. And our idea today here is that, so we are going to use Terraform to create a bunch of resources in the cloud, and this is going to be a demo-based session today that we are going to do. And I'm going to use AWS for this, and my idea is that I want to create and manage a bunch of machines in AWS and some security groups and things like that using Terraform. And at the same time, Terraform would be tagging all those machines. AWS allow you to create tags, right? I mean, just like AWS, any other cloud provider, Google or Azure, whatever provider that you use, you have the ability to create identifiers like tags, things like that. So you can create tags like this machine belongs to the production environment. That would be one tag, or another tag would be this machine is supposed to act as a web server, or this machine is supposed to act as a database server. So the tags can actually become an identifiers for every tools that you use in your company. So so I'm just going to take you to a quick demo where we use Terraform to create a simple machines, and inside that machine I'm going to configure a website, a web applications, and then it is Terraform who define the roles of the machines by creating the proper tags while it creates a machine. So let's get into the demo. So what we are currently looking at is a Terraform manifest of a simple EC2 instance. Right, I want to create 3 instances in the cloud, as you can see here, and then I'm properly tagging those machines. Right, I call them type equal to web server, so the machines are supposed to act like a web server, and environment equal to production. So this machine is supposed to be as part of your production infrastructure. So some tags that Terraform would add in AWS that would become a unique identifier of your machines in AWS, and not just that, your other tools like Ansible, Jenkins, or whatever other tools that you use in your company would use those tags as the unique identifiers of the machine. So that's how they discover what machines it is, right? And let me quickly walk you through the code here. So you can take a look at my VS Code. This is just a simple Terraform manifest. It creates a security group. One resource is a security group which opens the port number 80 and things like that. And most importantly, it is creating a proper tag to the security group as well. Type equal to web server and environment equal to production. So that is one resource that my Terraform is creating, and another resource is a EC2 instance itself, right? 3 machines I'm creating, and then I'm making sure that the machines are tagged with proper name, right? Because this machine is a web server and it belongs to the production environment. I create the appropriate tags here using Terraform, and these tags would be permanently saved in your AWS account by Terraform, and it would be managed by Terraform. And then I also make sure that the machines are created using a key so that my tools, other tools who want to log into these machines and configure the machines already have access, so I don't really have to push the key. I am launching those machines with a key which my tools already have access to. So you will we will later we will use Ansible to configure the machines, and that is when this key would become useful. Ansible uses this key, right? All right, so this is my Terraform manifest, and I'm going to apply this manifest by executing the Terraform apply command as usual. So that's what I'm going to do. I go to my command line and I'm going to execute this command, Terraform apply. Give me a second. So this is the folder I have kept my Terraform manifest. Sorry. And this is the main.tf file that I have just demonstrated, and I'm going to apply the Terraform manifest to my AWS cloud, which would obviously create a security group and 3 EC2 instances in my AWS account, and most importantly, it would tag those machines. So I'll just apply, and that is done. Now the machines are being created in my AWS account, and they are tagged with some appropriate tag, and that's great, right? Cool. So now my infrastructure is ready. With a single command, I provision my infrastructure to run my website. So it's a web application that I want to run into this infrastructure that I just provisioned. So basically apparently a simple 3 machines and 1 security group. And now let me configure these machines, right? So that's what I'll do next. I go to the configuration part of the machine. So generally configuring the machine normally means making sure that the machine has everything that machine should have, right? That's what it means. So if you want to run a website, you might want a web server, and you might want the web server service to be running in that machine, and you want to make sure that your website is copied to that machine so that it can serve your website to the people. So I'm going to configure a web server today, and I'm going to use Ansible. If you don't know Ansible, Ansible is a tool that you can use, and you can write YAML code that would actually define how your machine is supposed to look like. For example, if it is a front-end web application, you want that server to have a web server like Nginx, and you want Nginx process to be running in that machine, and you also want to make sure that some website, you are running website, should be copied into the Nginx so that Nginx can now serve this website to the people all over the world. So Nginx is a tool that can make sure that your machine has everything that it need, right? So that's what Ansible is. And so I'm going to quickly show you a demo about Ansible. And what Ansible does is, just like any other tool in my company, I would configure them in this way. I want Ansible to check my AWS account and look for those tags created by Terraform and identify the machine. So if the machine has a tag called web server, then Ansible will assume that it's a web server. And if the machine has a tag called production, then Ansible will assume that it is a production web server, and then Ansible will apply the settings what those machines need to look like. For example, every web server should be installed with Nginx, and every production machine should be copied with the production website, right? So these are the things that Ansible makes sure. So I'm going to ask Ansible to check my AWS account and look out for the tags, right? Look out for the tags of my EC2 instances and group the machines based on their tags. And then inside Ansible, I have created a bunch of playbooks to specify what those machines should be configured with. So if I quickly show you a demo of the code, my Ansible code looks something like this. If you, I have a file called setup web server. So basically, it is working on those machines that are tagged with web server, and there are two tasks that it will do. Nginx, it will make sure that Nginx is installed on those machines that has this tag called type equal to web server, and it will also make sure that Nginx is running on those machines if the machine has the tag type equal to web server. So these are the two tasks that I have in my Ansible, and Ansible automatically apply these tasks to those machines who has the right tag in my cloud provider. And similarly, I have one more Ansible playbook where it copies the production website if the machine has a tag of environment equal to production. So that's what Ansible do. So Ansible, I already asked Ansible to check my AWS account, figure out what the machine roles are based on their tag, apply the playbook to those machines. So that's what I'm going to do using Ansible. I go back to my command line. I go to the folder Ansible. So my infrastructure is now ready. The Terraform apply command is finished and infrastructure is ready. Now using Ansible, I'm going to apply the playbook settings. I mean, basically making sure that all those machines that Terraform created is now going to be configured using Ansible. And all I need to do is I need to run this playbook. There is a playbook called setup web server AWS that is responsible for installing and starting Nginx, and then the other one is responsible for copying my production website to those machines. So, and remember, now Terraform and Ansible are completely decoupled, right? Ansible does not need to ask Terraform where exactly which one are web surveys or which one are database machines. No, basically Terraform already created the necessary tag in AWS, and Ansible is directly talking to your AWS account, identifying the tags and configuring that. So that is awesome, right? So you want to decouple your tools. I'm just taking Ansible as this example. You might be using other monitoring tools in your company to monitor your infrastructure, and the monitoring tool wants to identify different machines in your infrastructure. So whatever tool that you're using, you get a proper decoupling between Terraform to those tools. So every tools can work individually based on the tags that you created in the cloud, right? That would be awesome, right? And this is done. And now the next task. So this task is for Ansible apply all the web server machines, it install nginx, and then I have another playbook. What it does is it will copy all those production machines. Ansible will copy the production website, right? So that's what the next command will do. Ansible playbook command would actually this time would copy the website. So we you got the point, right? So check the machines in AWS and find out their roles based on the tag and apply the settings, right? That's what you'd want to do. So that's pretty much that I want to talk about today. And sorry, I was probably a bit fast because of the time limit. So that's pretty much I want to talk about today. And if you want this whole thing to be integrated using Jenkins, for example, you want to simply run a Jenkins pipeline, your developer might want to do everything at one shot, right? For example, they want to store their code in GitHub, and whenever they make some code change in the GitHub, you want your Jenkins to provision a complete infrastructure and then configure the infrastructure in a fully automated way. So that can be done. All you need to do is just copy your commands into a Jenkins pipeline, as simple as that. So I can quickly show you a Jenkins pipeline. Over here you can actually see I have written the same steps that I have run manually, but this time you can check out the code from GitHub, but today I have just already kept the code inside my Jenkins server, and from the Jenkins server I execute the Terraform apply command that would provision a new infrastructure for your applications, and then it uses Ansible to set up those machines once Terraform provisions those machines. And then next thing, Ansible is doing two-step process. First step, it configure the web server. Next step, it configure the production websites. And right, you can at your convenience you can arrange the steps and things like that. So you can do a lot of things, right? So store everything in Git and have Jenkins configure, and maybe it is best for creating the preview environment. For example, your developer makes some code change and you want to quickly create a preview environment, create a Jenkins job that would create the preview and delete, right? You say Terraform destroy command at the end to delete the preview environment automatically. So that would be awesome, right? Your developer makes some code change, and within few minutes a new infrastructure built and it get configured, and a developer can see the preview, and then you use Terraform itself to destroy it once you are done with all the testing. So try that, and this is pretty much I wanted to talk about. So thanks, and bye.
Awesome. That was pretty good. I always love when talks take us back to the whole Terraform versus Ansible, and this was a good talk, which kind of talks about um, both Terraform and Ansible. So, what did you think, Arav?
Yeah, I think it's pretty interesting. Like so far, if I do a recap of the event, right? We have seen console, we have seen Nomad, we have seen Vagrant, we have seen like all cloud stuff, right? which
Yeah.
which begs a question like I am wondering, like, is there a favorite product from HashiCorp, Hari? Like, is there any favorite? I think it's more like asking like who's your favorite child on when you're live on when you're on the live stream, right? But I'm still wondering, like, is there something which is more closer to your heart? And probably I can go next.
Yeah, absolutely. I started off as a Terraform practitioner myself, so it's very close to heart. But I've always come from the networking world, so Console is one of my favorites. And unique about Console, it like Abhishek really nicely touched on it. Works really well with Nomad. It does the service discovery for it, among being service discovery platform from anything else. The other thing that Abhishek talk could build upon is console actually now supports even service mesh on Windows. So you
Nice.
can run Envoy on Windows and use console to do that. Console works really well with Vault, which I suspect is one of your favorites, both ways. And console also works really well with Terraform to do some network infrastructure automation. So my favorite would be console, not to pick a favorite.
Yeah. So
And what about you?
for me, I think I have been most closer to Vault for over like 5 years now. So before joining HashiCorp, I was using Vault as a customer, and now I'm actually working on the team that is building the HashiCorp cloud platform Vault. So I do work there, but for me, definitely Terraform is a game changer because I feel the ecosystem has such a wide variety of integrations at this point. It just seems as if like I was in one of the HashiCons before, and I saw someone actually do a game with Terraform, and I was like, this is like next level, right? We have like Domino's pizza
Yeah,
integration with Terraform. I think
that
last
is cool.
HashiTalk India, which was the first edition, someone actually did a Spotify integration with Terraform, so you can actually manage your like playlist. So I think that's where this gets a bit interesting because like I wonder if HashiCorp would have thought about building this tool with these purposes, right? So it's always
Yeah,
the community that takes it to the next level. So yeah, for me it'll be definitely Terraform, and yeah, it's
yeah,
exciting to see that we are seeing like content on Terraform Cloud and how simple it is. I think. Ashish did a piece on that, which is like, oh, we don't want to do anything local dev anymore. We'll do
yeah,
everything on demand, and
yeah,
it's the complete SaaS world, right? But whereas you see Kamalika, who's actually dealing with the customer, who's doing on-prem thing, which is like bare metal, so which is completely like anti-cloud motion. Uh,
yeah,
so it's really interesting to see that we are kind of in this hybrid world where some of the use cases are still like pretty much restricted to your on-prem data center, whereas there are companies who are actually just building things on top of like cloud, where
yeah.
HashiCorp can come up with these products. And best part, I love the analogy of Apple being a tightly integrated system, and I
Hmm.
feel we are the apples of the infrastructure of DevOps realm, because you can throw Vault with console, you can do like Nomad with Vault for dynamic credentials, and all of that fits, right? It might
Yeah.
feel like a pitch here, but I think I really enjoy, and I've been on the other side as a customer, so I'm really fortunate to be a part of HashiCorp.
Yeah, likewise. I also great summary on all the talks today so far. It's been phenomenal listening to all the speakers. One quick plug: there is HashiTalks series continuing with that. Our 24-hour global community event will be back for its fifth edition, February 16th and 17th, exactly of next month. So 16th and 17th of next month. So please go to hashi.co/HashiTalks-2023 for more details. Again, a 24-hour event. It's a huge following for that event, and a lot of great talks on that as well. So with that, I wanted to introduce our next speaker, Shubham Pandey. This talk specifically a little bit different from the talks we've seen so far, which have been very technical. But this one also touches on that and the governance side of things, especially with one of our leading connectors for Terraform. To your point earlier, Gaurav, the ServiceNow Terraform connector. So Shubham Pandey, who's actually a senior developer at ServiceNow, he's gonna talk to us about using that connector and providing governance around everything. So take us away, Shubham.
Uh, Hi everyone, this is Shubham. Welcome to my HashiTalk. Word of intro about me. I am a senior developer in ServiceNow Bangalore Development Center. My team handles ServiceNow IT Operations Management Products, also known as ITOM. So I hail from the beautiful lake town of Nainital in Uttarakhand, which is in the northern part of India. So I have around 7.5 years of experience working in IT with different domains. And I have various hobbies like sports, bit of music, trying out different cuisines of food, and a little bit of travel, especially the Himalayas. So that's a bit about me. So coming to the agenda for this talk today, uh, so this brings me to giving you more insights on what my team does. So as we all know, ServiceNow is the standard process workhorse for the industry. Our team innovates and develops products related to provisioning and governance of resources on cloud. We have various stories for IT, for the DevOps, and etc. I'll take you through some of these stories which we have achieved with Terraform and the technical nitty-gritties of it as well. But other than provisioning, we own a few products in the areas of cloud governance as well. And we constantly look for more and more solutions in this domain. Some of the other products based on this are cloud configuration governance, tag-based governance. So coming to the agenda here, we will start with the introduction to our product, cloud provisioning and governance. So this is our standard product for provisioning resources on the cloud, or we can say exposing cloud resources as a catalog. So this is to build the foundation for the Terraform connector. So next we'll talk more about how we have overlaid Hashi products on top of ServiceNow. I'll be focusing on the Terraform part of it, that is the Terraform connector. We will discuss about how we have created magic for our customers by combining ServiceNow with the capabilities of Terraform. So after the introduction to Terraform connector, we will move on to interesting stories for IT and DevOps that we have achieved via the Terraform connector and this integration. One of the interesting stories is change governance, where we observed that we were able to reduce the production deployment time of our customers from 3.5 months to 3.5 hours. We'll discuss more about this story among others, and then next we'll move to the technical how part of it. We'll dig a little deeper on how it works, and then we will be concluding this talk with a quick demo. So we'll be using the standard ServiceNow Employee Center to find the catalog offering to request a multi-VM stack on AWS, which goes through Terraform. Now, after provisioning, we will see a more advanced view of the request and the stack in the Cloud Admin portal. We will also explore other capabilities like day two operations on the stack. So let's move on to the introduction to cloud provisioning and governance. So quick introduction to cloud provisioning and governance, which we fondly call CPG in short. So this slide gives a holistic picture of the features and capabilities. So in a world where cloud activities are driven through code, right? So like scripts, calling APIs and JSON, YAML templates and everything for deployments. So we provide an ability to run all the cloud activities on top of the secure ServiceNow platform. So we have out-of-the-box support for various IAC technologies, and this is where Terraform will come in. So we support cloud-native technologies like CFT, ARM, and everything, and we support the multi-cloud technologies like Terraform. So this enables the complete lifecycle management for cloud resources. The principle here is that ServiceNow enables this non-intrusively. So any app developer can initiate this from a DevOps pipeline. But underlying ServiceNow governance capabilities will be run to ensure rules and policies for the deployment are met. So we also have day two operations like start, stop, terminate, or update a cloud resource. And there also we have multiple approaches like scripts, integration hub flows, which is like another low code, no code interactive platform capability, and our exhaustive API layer called Cloud API, or integrations to Ansible and all these things. So this is a single platform from where all the cloud operations can be run. So like day one provisioning flows, or day two operations, or creation of cloud offerings, or the governance aspect like policies, tagging, you name it. Okay, so so last slide was more about the product capabilities as a whole. To set up the foundation, here's a more solution-oriented picture. So in brief, this is our cloud provisioning story. Again, wanted to highlight on the same platform story here, single platform story, one platform for all the cloud operations, which manages end-to-end life cycle of the cloud operations. So I'll quickly move on to the next slide, in which we apply the Hashi solutions overlay on top of this. So this is where magic happens. When we introduce Hashi solutions here, I've mentioned both Vault and Terraform. Some of our customers use HCP Vault for their credential management, but I'll only be covering Terraform connector in this talk. So when we introduce Terraform connector on top of ServiceNow, it enables us to ingest multi-cloud Terraform templates and expose them as catalog offerings, catalog items for our end users. and then again use Terraform to deploy or update resources on the cloud via calls made from the ServiceNow, from our mid server. We support both Terraform Cloud or Enterprise offering as well as the Terraform open source server. So a simple story would be a simple IT request. Let's say an employee requiring a virtual machine for some of their internal work or testing or something. They can simply find the respective catalog item in their ServiceNow instance, and they can request, and the corresponding Terraform template will be called, and the request invokes a call to Terraform, and VMs are deployed on the cloud. The provisioned resources are also automatically updated on the CMDB. So CMDB is always up to date with the latest changes in the cloud as well. So I wanted to focus on the point that this is not just a solution for the IT. This is also a change governance solution for the DevOps. So consider this: whenever we are pushing out resources via Terraform in a declarative mode, we are making changes to the environment. So in enterprise, these changes can be significant, right? They can carry significant impact. We may not know what services are we impacting, or whether we need approval and all that stuff. What ServiceNow capabilities have to offer here is a governed approach on deploying and taking actions on the cloud. The typical approach that we follow is that the user goes to the catalog and searches for the appropriate catalog item. And when they find the matching items, they can make a request for a day one operation, like a deployment of a VM or a pass, or a day two action on the stack, like let's say adding a disk to the VM or turning on encryption on an S3 bucket. It all goes through pre-approved set of changes. So for dev or test infrastructures, this is a bit of an overkill. So an engineer could use a test account and all for testing changes. When it comes to production, that's where ServiceNow plus Terraform magic comes into picture. And like I said before, it has helped the production deployment times of our customers significantly. Simply because earlier approvals were stuck hanging on each desks and all that, but now it's end-to-end automated. The actual call to Terraform is also automated. So the question is, how do we achieve that? So how do we convert Terraform templates to catalog items? So this slide gives a brief idea on that front. So here we have taken the example of Terraform Cloud, but we do support Terraform open source as well. The concept remains similar. So first of all, there is an admin who will set up the Terraform as well as the VCS credentials on the ServiceNow instance. So in version control systems, we support discovery of templates from GitHub, GitLab, and Azure DevOps. We also support, other than the cloud versions, we also support enterprise self-hosted versions of them as well, in GitLab, GitHub Enterprise, and GitLab community and other things. So admin will first run a discovery on the Terraform cloud to list out the workspaces and stuff, and list of the configured VCS accounts from the Terraform side. So then he will associate the VCS credentials with the particular VCS account, which is discovered. And then the next level VCS discovery is made to discover the list of repos and branches from that VCS provider. So we call these repos IAC artifacts or config installables. In case of Terraform open source, this thing is achieved with a single level discovery, where the admin will configure the SSH credentials of that Terraform open source server and discovers these artifacts from the specified root directory. So we'll read files from that directory and list everything again as a config installable. So then we come to the catalog designer. The designer will create the catalog item from that discovered template. The designer will make use of that template. So ServiceNow here will read the template, figure out the provider, modules, and other stuff, expose out the variables there, and makes those variables available as a part of that catalog item. So we can see here the list of all the jobs of the catalog designer, other integration scripts, tagging policies, day two actions, and everything. So keeping the catalog item updated with the latest changes from the VCS. So we also have a concept of scheduled IAC discovery, in which the discovery of templates from the VCS is done in a scheduled manner automatically. If changes are detected, then change tasks are automatically created, and catalog owner is assigned those change tasks, and we can take the action to keep the catalog item updated. So now coming to the governance user. So governance user will set up the policies for all the provisioning and day two operations, as well as the other tasks defined here. So now coming to the end user, who is the requester. So this is the part where the end user will come and request the stack via the offering in the catalog. It's a pretty end-to-end process. The provisioning magic here is that the request handling is done in such a way that we are actually working very closely integrated way on top of CMDB. So the request is sent to Terraform, provisioning is done, and as soon as the provisioning is done, the objects are automatically updated on the CMDB. So we have ways to make targeted discoveries from the cloud on those provisioned resources. So that way our SRE operations or observability and everything, that is also updated with the real-time information of our cloud with the help of real-time CMDB. Okay, so after that, ops team can take over and work on top of these resources. They can take a Terraform route or another route. So this is how the flow, a typical flow happens. Okay, so here is another view of a step-by-step thing. So on the Terraform end, currently we are not reached the ServiceNow end. This is the configuration of the Terraform end. The Terraform admin will configure the Terraform enterprise account or cloud account, and it will associate the VCS systems like, let's say, GitHub or something. And then the Terraform designer, the person who is designing the templates, right? So the Terraform designer will create the templates as a GitHub repos. And they'll take care of the modules, resources, variables, and everything. Now we come to the ServiceNow side. So on the ServiceNow side, the cloud admin will, like we discussed in the last slide, cloud admin will discover the using the TFE provider. Cloud admin will discover the VCS systems, and then the second level discovery of that particular VCS system to get a list of repos, the config installables, and the catalog item designer. So the discussed again, catalog item designer will again create the catalog items, generating the variables and everything, and the catalog item will be created. So again, I would like to mention here that this is more a strategy for production changes, and typically not for development. Here is a typical example of a branching strategy. The branch naming here is something inspired from how we do app development at ServiceNow internally. So the naming conventions could be different, but the concept remains same. So in all the development can be done on the dev branches and everything, but validation and everything in UAT and staging branches. And then once tested and approved, it is moved to production branches, and then it is submitted to ServiceNow. So this is where ServiceNow takes over the governed workflow including Terraform. So the state file and everything is also maintained. We do not come in the way of any state file or anything. We leave the state file, we update the CMDB, ensuring that we discover the infrastructure that is provisioned, and we discover it and keep it in the CMDB. So here is another slide to understand that. So we are assuming code changes via ID and some build pipeline like Jenkins and all that is done outside of ServiceNow. And then finally, the release deployment, that is where this comes into picture. This is the place that ServiceNow helps. And by bringing this part to ServiceNow, we take all the advantages of the capabilities that we have discussed. Just by creating this infrastructure as a ServiceNow catalog item, we take all these benefits that are listed. The security, the compliance, governance, all the approval rules will be applied, the permissions can be set up, everything will be audited, we'll take care of change management on its own. So everything will be taken care of. So let's see all of this in action with a quick demo. So we will use ServiceNow with Terraform connector to discover from a Terraform cloud account, and then we'll discover templates from a GitHub account. And we'll create a catalog item using a template, and then using the catalog, let's provision IT. So in the demo, first we will take a ServiceNow instance, and we will connect the Terraform cloud account with the help of a Terraform config provider. So we will go to the cloud admin portal. This is where the cloud admin and catalog designer primarily work. and I'll go to design, I'll go to manage, and I'll go to config management. This is the place where we create different cloud config providers. So we will open up create config provider. So I'll choose SPTFE demo, the name of it. And in the provider, I will choose Terraform Enterprise, which represents both enterprise and cloud. So I'll enter the organization here. In the URL, I'll put the API URL from which we can access the Terraform APIs. Okay, this is the base URL for the Terraform APIs, as we all know. In the server type, I'll choose cloud. This is a cloud account. In the credential, I have entered the credential for the API key of that account. So I'll link it to that. In the versions, these are the versions that we support in Terraform connector. The latest version that we support right now is 1.2.0. Any new version support can be very easily added, by the way, but I'll go with 1.2.0 for now, and I'll submit this. As soon as I submit this, I will go to this inside this provider, and I can see the Discover Now button. This button will, on clicking this button, it will trigger a discovery on that Terraform Cloud account, and it will bring out a list of all workspaces, the configured version control systems, agent pools, and everything. So we'll wait for this one. Okay, we can see that it has brought a list of all the workspaces and everything. It has done the discovery from the Terraform Cloud account. So we are more concerned with the VCS systems right now. This is a list of all the VCSs that are configured in that Terraform account. I'll choose one of the GitHub accounts that I use. So this is a GitHub account that is configured at the Terraform side. And we can see that this is that GitHub account. And I will enter the configured GitHub key here. This is the credential for the GitHub key that I've entered. And as soon as I save it, I will see that I have a Find Branches and Repositories button. Once I click this button, it will try to bring all the branches and repositories from this GitHub repo. Let's wait for this. Okay. Okay, so we can see that all the Terraform templates, all the repositories in this GitHub account with all the branches, they are discovered here. And now we will create a catalog item with the help of one of these repositories. So for that, we'll go to Design and Cloud Catalog Items. This is the place in the portal where the catalog designer mainly creates and designs the catalog item. I'll create a new catalog item. In the new catalog item, I'll just name it SPTFE demo catalog. Okay, and in the source, we will choose configuration management template, because the others are for the cloud templates like CFT, GDM, and other things. In the provider, I will choose that the provider that we just created. So let me just open this related list. Okay, I'll choose SPTFE demo. This is the provider that we created. I'll quickly save this. Okay, so this is now saved. And now we have to fill this catalog item with a cloud template. In the related lists of cloud templates, I'll go to new, and I will see that I have to give a config installable. So all those repos that we discovered, repos and branches, they are the config installables for this provider. As soon as I open this, I'll see a list of those repos. I am going to choose one catalog that I know. So this, the master branch of this template is what I'm going to choose. So as soon as I click save, we will see that it will bring everything from that repo, and it will compile all the templates in that repo into one overall template. And it has created all the variables from these templates. Okay, now we will activate this catalog. We'll wait for a bit. It parses everything in this template, the variables and everything. It does all its processing, and let's wait for it to get activated, and then we'll see it will be available for us to be used in that catalog. Okay, so this state of this catalog is active now, and we are back to the catalog item screen. We can see that this catalog item has now got variable sets and everything. So this is the place where catalog designer is supposed to add more to this catalog, some post-provision operations or pre-provision operations, rules, lifecycle operations, which are the day two operations. Everything the catalog designer can do. This catalog is activated now. In the variable sets, we will see that apart from general info, we'll see if we go to the provision part, we will see that all the variables in that template are now exposed as cloud variables in this catalog item. So now we are ready to activate this catalog item as a whole and publish it. As soon as we do that, it will be available for any user, end user, to be used as a catalog offering. Okay, let's go to the cloud user portal and find this catalog item and see how it appears on the catalog form when the end user will request it. Okay, so we go to launch a stack, and this will show us a list of all catalog items that are available. So this is a list of all the catalog items, and this is our catalog item. We click on launch and it will open the catalog form. So this is the general info section common to all the Terraform catalogs, like do you want to use existing workspace or the cloud account and everything, all the details, right? So if we go to that provision tag, this is where all the other form related details are there. These are all filled with the default values. The requesting user can of course change all of these values as per the need. So in the last part of this demo, we will provision one of these catalogs from the end user and how the request form and everything looks like. So we will initiate our request with the employee center. This is a standard ServiceNow homepage which any employee can access. So if someone wants a laptop, they will go to this portal. Someone wants an AWS VM, they'll go to this portal. So this is a unified kind of that form. So one of the catalog items that we have created, we have made it a part of this service catalog. This is an AWS TFO multi-VM catalog. As the name suggests, this goes through Terraform open source box that we have. And this is an AWS VM catalog where we can request a certain number of VMs as a part of our stack. So we will open this catalog item. Right, so this will load a list of cloud accounts. We can choose the location here. We'll see all of these items. We'll select the user group, a user group that is created. Let's select 3 in the number of VMs that we would like. In the size, let's go with t2.nano for the purpose of demo. Right, and this use existing workspace, right? I'll choose no because I want to create a new workspace. Use existing workspace is marked as yes for the change governance use cases. If you want to update an existing infrastructure in the change of the templates or stuff like that, we've discussed about it in the past slides. We have this lease end date and then scheduling profile like 8 to 5 or such kind of things. we can configure our stack to be running only at these scheduling profiles. So these options are there. We will click on order now to initiate this request. So once we click order now, we have got a request number here. To see this request in detail, we'll have to go to the user portal, the same portal that we discussed before. So I'll refresh it, and I will see that in the activities section, it has created this request that we had. The request goes through approval and everything. We can have certain approval policies in place as well. This is by default approved in our case, and it will show us the details of what is currently going on with this stack. So we can see that all the approvals here are done, and the capacity checks and everything. And right now it is deploying the stack, which means it is currently talking with Terraform and Terraform open source server and asking the Terraform server to run the Terraform provisioning commands so that the stack can be provisioned. So as a result of the commands that were executed, we have successfully provisioned the 3 VMs that we requested. We can see the resource IDs as well. And currently it is invoking the targeted discovery for these resources so that everything can be automatically, instantaneously updated on the CMDB as well. So we can see that our stack is successfully provisioned. All the resources are there. To see the details of the stack, we will click on view stack details. This is how our stack looks like. These are the storage volumes. These are the machines, my machine 0, 1, 2, the NICs, and this is the whole stack. We can also see that everything is already in CMDB now. If we click on view dependency, it will load the dependency map of our complete stack, where we can see our machines and everything. So that is one part, that everything is immediately moved to CMDB as well. And we can see that other than the provision, we have these day 2 operations as well on these deprovisioning of the stack and other things like lease modification and everything. Other than this complete stack level operations, we can go to a particular machine or particular resource in this stack, and we can select the resource level operation as well. Like we can stop one particular machine from this stack, and we can similarly perform these day 2 operations on particular resources. Okay, so this is how the cloud provisioning use cases work from ServiceNow. We have successfully provisioned a 3 VM stack using Terraform open source with the help of ServiceNow. And we have also discovered all of them immediately and kept them all in CMDB as well. So this is the end of the demo. So thank you everyone for listening to my HashiTalk. And for any more information, my email is mentioned here. Thank you all for listening. Have a great day. Bye-bye.
Thanks, Shubham, for walking us through a demo on ServiceNow and the integration with the TFC for the governance and security compliance. I haven't used the platform before, so it was very enlightening for me. I think the dependency map at the end was definitely something that caught my eye. Uh, Once you grow at a scale where you are churning out more things in cloud, you are doing multi-cloud provisioning, I think manual security checks and compliance could be a bottleneck to your automation, right? And that's where probably this mix of ServiceNow and Terraform could could help the enterprises. I think when you are operating at that scale, automatic guardrails are the way to do multi-cloud provisioning. So if anyone is interested to do something similar for their organization, please reach out to Shubham. With that, we'll move on to our next speaker, Anju Modi, uh, who is going to talk about automating the secret management with HashiCorp Vault and Concourse CI. Uh, I am at a point in my journey today where I have to say adios to you all because I think it's way past my uh, time. So I am leaving you in good hands with Hari and Jasmine behind the scenes to continue the rest of the event. So keep up the good energy, keep up the questions. I think we'll really. I have been a fortunate. I've been fortunate to be a part of this, and I look forward to hearing from you all. Over to Anju.
Hi, everyone. Just want to check that if I'm audible. Hello? Yeah. Okay. Thanks, Gaurav. Just one small correction that my name is Anuj Modi, not Anju. I've been called earlier as well. But just to, on a light note, that my name is Anuj Modi. So thank you, everyone, for joining HashiTalk. Uh, it's a great to connect with everyone here. And we have a lot of really good sessions happens. To continue on those sessions, I'm going to take to the next level where we're gonna talk about on the secret management and how we can automate leveraging the Concourse CI pipelines tool. So a little bit about myself. My name is Anuj Modi, and I'm a solution architect at Cisco Systems. I closely work with the global partners and helping them build services around observability and AI ops. Uh, Along with that, I actually help them build their uh, ecosystems, right? Where we help them to the partners to build, do a lot of POVs and POC, and that's where we were working with them to help building their automations, leveraging the concourse and the HashiCorp Vault, and I'm going to walk through this in the upcoming slides. Uh, I'm having more than 20 years experience. I've been author of a book on Cisco UCS solutions. I have presented at multiple conference and below some of my coordinates. Let's get started here. So simple agenda, I'm keeping it right. This is on a starting from the HashiCorp Vault basics, and then we'll talk about something about why the concourse. And one of the request that if we want to build something for any partner or for any customer, right, how do we can start the journey? But we are not looking any kind of development. We are looking at productions grade cluster environment. So that's where I have put it into three main parts here: deploying the Kubernetes cluster, which is where you can build the whole architecture. The second, we're gonna build the Vault production server. It's not the dev servers, but yes, you can do test with the dev servers. And then the deploying the Concourse CI, so which will be integrated with the Vault. And we will talk about this in upcoming slides. And then finally, once we have done these things, we can automate the whole CI/CD workflow for any requirement for any partner or for any customers. So doing any POVs, or they want to have a production setup in their environment for any development kind of works. And then a little bit question answers. Okay, so let's get to the basics. So one of the thing is that most of the partners, right, they do work with a lot of eco partner systems, and within that, these developers, they do authenticate with multiple products. And one of the key requests from that is that they get to authenticate these applications with the third party tools and products. So here, if you can see an examples, I have put it in a product called Thousand Eyes .com, which is a Cisco's product used for the customer digital experience monitoring. So if I want to access this product, right, and want to integrate with my ecosystems, I would need to have a token to access that applications. And normally this token is actually put it in inside the codes, inside any of the codes. If you see that this code can be put it normally into a plain text and embedded into the codes, but that's not a recommended way to do any programming. So it can actually can a risk for any organizations who is building such kind of product. So there's a multiple way to overcome this. That's where we're going to look into that. And some of the challenge we can think about if we are doing this API authentications. The first thing is that we embedded this into the source code as a plain text. And if we are putting this as in a plain text, anybody can have access to this, and they can do anything. So if you anybody get access to this of the code, right? So they can do anything on the platform. So the other thing, normally when any developers write any codes, right, so they push the code into the version control system. It can be a GitHub, or it can be any other version control system. So if you are publishing your repository into the GitHub or anything, right, it is not on a recommended topology, so that anybody can go into your public repository and can get access to that product and can do anything into the codes. And another one of the challenge is that if you have a number of developers in your organizations and you want to one of the developers may not able to authenticate, or maybe has doing something wrong with the programming, right? There's no way that you can audit the authentication mechanism. So that's where some of the challenges where real enterprise organizations are facing. They are not able to keep a good audit trails of the authentication mechanism. And as we are putting this in an encryptions, most of the time the developers, right, they keep these codes in their own laptop, or either they keep in the version control system, and there's no encryptions as well. So most of the applications, they would like to have encryptions built into the systems, but that encryption is not easy to configure. So that's where they are looking something which can be helpful to provide encryptions. And another challenge is the common challenge is the token get expired. So you have hundred of developers, right? So your system admin may be able to provide you the token. And if he has to provide the tokens, he gonna spend a lot of time to create the new tokens for every developers, and then when this token get expired, he has to renew these tokens. So there is a lot of operation heads for doing the overall secret management. That's where the HashiCorp Vault comes and helps us to do the complete secret management. The first thing, it's a cloud agnostic and API driven secret management platform that safely store and manage sensitive informations. So the couple of use cases about the HashiCorp Vault is, one of the main thing is that it does your complete secret management. The secret management, it can be your password, it can be your tokens, it can be your certificates, it can be any database credentials or anything. So you do not need to keep all these sensitive informations in your laptop or in your any repository. The HashiCorp Vault provides you that complete centralized management. Then it can provide you identity-based access management. It can provide you access management, either it's a user, or either it's applications, or either it's a cloud platform. There are, and as an individual developers, they may have a multiple uh, platform they are interacting, where they need to access these. Either it can be the applications, it can be a database, or it can be any cloud service providers. That's where HashiCorp Vault can provide you identity-based access for different platform, different technology. Not only that, some of the applications may require one of the key thing is to have the data encryptions. Either it's in REST communication, or in at any in place. In that case, the HashiCorp Vault can also provide the data encryptions functionality. Then other few use cases around, it can provide you dynamic short-lived credentials. So you do not need to have the static credentials, where it can be for a month period or maybe for a 6 months period. You can have short-lived credentials, so that if anyone get access to those credentials, they may not be valid after a certain period of time. And then the final thing is that you get the complete audit logging mechanism. Any user who is actually getting access through the vault, it there will be a history, there will be a logs, and there will be a complete a trial for the HashiCorp vault for any kind of communications happening to any of the applications and products. So this is pretty much about the HashiCorp vault, but let's go into further, right? The this HashiCorp vault is a secret management. It's another additional complexity and additional operational overhead. How we can overcome this additional overhead? That's where we are coming into leveraging some of the tools from the industry tools, the Concourse CI. The Concourse CI is another open source pipeline based tool which can use to scale any kind of automations pipeline from simple to complex. You might heard about a lot of other CI/CD tools like Jenkins, Circle CI, GitOps, Actions, and other tools as well. But Concourse is another platform or tool which can help you not only providing you simplicity, but it can provide you scalability as well. And it is a plugin based architecture which work on similar format like resources, uh, jobs, and tasks what you have do work in other CI platform. And the it provides you the ephemeral container where you can run your task. So if you want to do any task on any of your development task, right, it will create the ephemeral container on the fly, and once the task is completed it will go away, so that you are not consuming any resources when you are not doing anything. It leverage Postgres as in a backend database, and it can provide you complete automated the pipeline, and you can see the whole progress either through the CLI or graphically. And one of the biggest thing is that it's easy to troubleshoot. So Concourse can help you to integrate your uh, secret management HashiCorp vault to the pipeline, and then you can execute your task directly with uh, your choice of any ID platform. So we're going to see these things how this can actually work. So let me just take you to how these things will happen when you integrate your HashiCorp vault with the Concourse. As in the application developers, either it's any devices you want to access any applications database or any other platform, with these integrations, right, you can actually do automatic task. It can provide you continuous testing and continuous deployment access without any manual interventions. So whole authentications and authorizations can happen through the vault will be integrated with the Concourse, and we will gonna see how this can be implemented in upcoming slides. So before I go to that, this is how it will look like. If you could see the Concourse CI uh, GUI, where you can have your resources, and these resources will be uh, can be it can be your version control system, it can be any other resources. You can define your custom resources as well into the Concourse, and then once you have the resources available, then you can create your own jobs. Within these jobs you can create your multiple tasks. When task can be anything. Let's say you want to maybe execute a small script where you want to create maybe a new tokens, or maybe something you want to create, you want to modify any existing services on this. So whole thing this can be built on the Concourse platform. And uh, how we can build this, so I'm gonna talk about this in upcoming slides. So uh, the first thing is that if you wanted to build whole architecture, you're gonna need to have the Kubernetes cluster. How I have done these things, I have actually leveraged uh, one of the AWS platform, where I actually deployed a Kubernetes cluster leveraging one of the uh, Kubernetes deployment platform called Corps. Corps can help you, can help you to provide easy way to deploy your Kubernetes cluster and all the behind actions. So if you see here in this example, I have shown you a small code. You can configure your Corps user ID with the AWS. You might need to have the AWS CLI on your laptop. And once you have this AWS CLI laptop, you can create credentials with the corps, and then you can deploy the corps as a separate tools, which can create a cluster. So if you see here, these scopes can create a cluster. You can provide some of the variables, the names, and you can define which service provider you want to leverage. The corps can work for any service provider. It can be Google, it can be Microsoft Azure. However, I have used AWS, but you can use any cloud service provider. And then you can define which particular region you want to deploy this tool. So once you have deployed the Kubernetes cluster, the next step is to deploy the Vault as in a production server. So for deploying the Vault, you can simply run any simple Vault uh, 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 configurations files. But what I'm doing here, I'm using the Helm charts, which is provided by the HashiCorp Vault. This Helm chart can provide you many functionality, including if you want to set up your own DNS, right? If you want to set up your own HA availability, and then you can modify the Helm chart configurations files, and then you can download this Helm chart, Vault Helm chart, which is available. So I'm going to show you in the next slides. Then you can deploy this HashiCorp Vault using these values. So once you have done this, you can have your Vault in the productions running. So let me quickly show you. Let me maybe present in a screen so you will have a better idea. I'm going to share my entire screen. Um, okay. So if you see here, here is my Vault is deployed. And let me go to the repository first, so you will have an idea. I have a HashiTalk demo repository uploaded. This is how you can deploy. The first thing, if you go inside the deploying the Kubernetes 8 cluster, you can have the whole cluster can be deployed leveraging this repository. I have given the commands. If you are want to use these commands can be used to deploy the Kubernetes cluster. So once the Kubernetes cluster has been deployed, the next step, you can go back here and deploy the Vault in the productions. So deploying the Vault in the production, you might need the Helm need to be installed on your system, and then you will configure your Vault configurations. Uh, this is very descriptive. There's a long way. I'm not going into the details of everything, but if someone is interested, right, they can reach out to me. I can help them. But once you have done, you will see this dev vault cisco live demo.com is deployed, and then you can do the configurations of the concourse, which is here. I've done the concourse configurations for the secret management. You can have the access. You can create a multiple authentication mechanism. Like you want to enable any new authentication mechanism, you have everything you can configure here. You can configure AWS, Google's, or you can configure anything related to the Kubernetes infrastructure. And then you can have the policies applied to that path. So this is where you can configure your Vault. Let me go back to the slides. Just going back. Okay. So now, once you have done the vault production deployment, there is additional configurations need to be done. Uh, let's me go into that one. That's called the app role authentications for the concourse. Now, there are multiple way to get uh, the secret information from the vault. Either you can get directly information from the vault, but if you can enable the concourse with the vault, you do not need to interact with the vault. You can interact with the concourse in the backend will automatically interact with the vault and provides you the required tokens, right? So for this, you might need to do the vault auth enable app role configurations, and then you configure a write policies, the vault write authentications app role on. You create a policy. This policy has an expiry for a period of maybe 1 hour, 24 hours. You can customize how you want to do, and then you will create these vault uh, uh, two commands. One is to read the role ID, and second is to create a write secret ID. These role ID and the secret ID will be leveraged into the concourse ham chart. I'm gonna let me just quickly show you as well. So if you go here, uh, this is here. I have configure the dev vault CI values, and this is where you can actually configure the role ID and the secret ID. And similar way, you need to also configure your URL. Let me show you here something. Yes, so you need to here configure your URL. You can search like dev CI. This is where you can configure your external DNS names uh, according to your organizations, and you can also provide uh, the vault address here in this ham charts. Once you have done this, you can go back to let me just you go back to here your yeah. So you go back to here your next deploying the concourse. You will have similar way ham chart downloaded for the concourse, and you will add the repository of the concourse, and then you will run this ham chart command using this uh, sorry uh, this values with this, and where this values will where you will be having the vault configurations shown into that. And once you have done, your concourse will be ready, and with that what you can achieve in the finally is you get your automated CI/CD workflow. So where as a developer he can write down any code to the version control system to the GitHub. He will pull and push any code upstairs to the GitHub, and then he will run some of the fly commands. Fly is a CLI tool which used to run some of the commands uh, to to provide the mechanism on the concourse. Either you can use GUI or you can use the fly commands to trigger any pipelines. uh, this will log in into the concourse, and from the concourse you will have some of the YAML files. These YAML files you will build where you will have some of the resources, jobs and tasks defined. And then what this will do, this will get pull your repository. It will pull your any changes what you have done into the GitHub. It will also download a Docker hub, a Docker container, which you can define. It can be your uh, Linux operating system, which will execute your code, and which will also fetch your secrets from the vault automatically. So once you have all these things will be pulled, it will build an FML container. This FML container can authenticate to your applications and run your integration test. So whole thing is will be automated as an it can be a one single developer or it can be a multiple developers. Once they start running this environment in a productions, they can do whole things without any administration interventions. They can update their codes, they can build the Docker containers, and they can run the whole task. So let me again show you something here. I'm switching between the screens. So like here, you will have, this is your concourse deployed on that. And if you go here, you can go to the Git resources, right? So that you can get all the Git resources into your system. And then you have your lab prepared, right? Here you can go. You can execute some of the task into the lab. And if you want to execute the task, you can click on the rerun task. And then if there is any issues, you can troubleshoot from here, or you can go back to your to your system and you can run from here as well. So uh, this is pretty much from my side, right? I'm open for any questions. Let me know if there are any open questions, or if you have any queries, let me know. Thank you very much for your time. Over to Hari and Hari, right? I think Hari and Jasmine.
Awesome. Anuj, thank you so much. Thank you for taking that one on the chin. My name gets confused sometimes all the time as well. Only thing I can guess, he saw your last name and got distracted. So, but phenomenal talk. Anytime you can use an open source tools to bring a solution together, especially something like automation, it's a great thing that the community can use. Your talk showed how you can bring so many different open source tools together to achieve end-to-end automation for DevOps pipelines. So I loved every single minute of it. Great job. We've had some really great talks today, like we've been saying all along, and we've touched on a lot of products, a lot of great use cases, a lot of ecosystem integrations. To round it all off, we have a couple of more talks, and they're going to touch on some very important aspects on Terraform as well. So next up is Preeti Pragya Jha. She is a lead developer and AWS solutions architect at TCS, and she is here to talk to us about getting started with Terraform on AWS, but the right way.
Hey everyone, welcome to HashiTalk India 2023. Namaste. Thank you so much for joining me for this talk today on getting started with Terraform on AWS in right way. As you know, Terraform is an open source infrastructure as a code tool that supports multiple cloud providers, for example, AWS, Azure, GCP. So today we will talk about how to kickstart your Terraform journey on AWS in right way. So are you excited? All right, let's go ahead. Okay, before we dive in, let me introduce myself. My name is Preeti Pragya Jha, and I am a technical architect at Tata Consultancy Services. I like to wear multiple hats, and that way I work in backend development, and I do architecture as well. Apart from that, I have been quite involved in DevOps work, and as you can see, I am an AWS community builder in DevOps. Apart from usual work, I do blogging, and I'm a co-founder of Cloud Katha, a cloud computing blog where you will be seeing mostly the articles related to cloud and different cloud-related technologies. Okay, so what's the agenda? As you might have guessed, it's all about starting with Terraform on AWS in right way. So we'll discuss about all the why, how, benefits, best way, and everything that helps us. Okay, so before we start with Terraform, let me give a little bit of overview on infrastructure as a code. A fundamental principle of DevOps says that you should treat your infrastructure the same way you treat your code. That means you have to version control your code. You need to write unit test against it. You need to, do all that you do with your code and with your performing all those that you perform in your code. So what infrastructure as a code helps you is it lets you provision and manage your infrastructure as a code. That means you can use code to create the same server that you created once 20 times or maybe 1,000 times. So it boosts your productivity because you automate things. Then, because you have automated your infrastructure, you create the same kind of configuration every 1,000 times that you create. That means there is no chance for configuration drift. And having said that, it also eliminates the possibility of a human error. Talking about the various ISC tool available on AWS, AWS has their in-house tool, for example, CloudFormation, SAM, that is mostly used for serverless, AWS CDK. Then coming to, there are external tools like Terraform, AWS CDK for Kubernetes, CDK for Terraform, Ceph, Puppet, and Ansible, etc. So having said there are so many tools, why go for Terraform? You might have a question, right? So few of the things that interest me are the Terraform is open source and it has a wide community that helps and support the Terraform and creating the different kind of provider that you have. And that's how, as of now, there are thousands of provider written by HashiCorp or the community. So, there is a huge support in case you need. And one of the most enabler of Terraform is that it supports multiple cloud providers. So you can create your server in AWS and point that into using a CNAME in Azure. That's quite possible. And that's the beauty of Terraform, my friend. Apart from that, Terraform syntax HCL is quite easy to use and less error prone. So why should we not use Terraform? Okay, so how Terraform works. If we see what we do to create a simple resource in Terraform, as a practitioner, you create or you represent your resource declaratively in your Terraform configuration file. And after that, you do simple init, as you might know, to download the provider specific code. And once done, then you run Terraform plan that will show you what exactly you are trying to create or update or remove or whatever. So if you are happy with the plan, you can go ahead and do Terraform apply. And that's when Terraform is going to create your declared resource in your specified provider, which can be anything like AWS, Google, Cloud, etc. And you will have your infrastructure ready in no time. Okay, so how do we get started with Terraform on AWS? If you have worked on AWS, you would have noticed that if you work with CloudFormation, you don't have to install anything. All you need to do is you just go and create a stack using your specified provider. But with Terraform, you have to install Terraform. Okay, so you can install Terraform from the official website that I have mentioned over here. Once you go there, you will see that there are various options of installation, like manual installation, and there are various options of operating systems as well. So depending on what's your operating system, if you are on Mac, you can also use Homebrew. If you are on Windows, you can either manually install it, or you can use Chocolatey as a package if you already have to install it as well. Okay. The next part, which is authenticating with AWS, and it is one of the most important part when it comes to creating a Terraform resource. So Terraform creates your resource by interacting with AWS API. And of course, for security reason, you can't interact with AWS API without providing your credentials. So you have to authenticate with AWS in order to create any API that you want. And for that, HashiCorp provides a lot of different ways in which it can find your configuration. For example, you can provide your access key and secret key in the provider configuration. It can look for the credential in environment variable or shared credential file or config file. If you are using container, then it uses container credential or on EC2 instance profile. So it all depends on where you are trying to create your resources. All right. Based on that, there are three recommended way. Okay, if you are working on your local system, go for installing AWS CLI and run AWS configure to configure your AWS CLI with your credential. If you are running Terraform on a container, then your container role is sufficient to provide all the authentication information for Terraform to be able to create it. And similarly for EC2, you can use EC2 instance profile. So let's see how you can do a local setup. Before you can set up your credential, you need to have a Terraform user or an access and secret key setup, right? Okay. So you can navigate to IAM and create a Terraform user. I have named it Terraform, but you can name it anything. It's up to you. Then here, as you can see, in the select AWS credential type, choose only access key as programmatic access. Do not consider the password or AWS management console access. You don't need your Terraform user to log into your console and perform some manual operation, do you? Of course not. So choose this and click next on permission. And to start with, you can go ahead with administrator access because Terraform needs to create different kind of resources and you don't know in beforehand what's the permission. So choose administrative access and go ahead with creating a user. But remember, in long run, this is not you should be doing. You should follow the principle of least privilege. Okay. So if you know that your Terraform user is only going to create S3 bucket, provide only S3 related permission to your Terraform user, right? Click next, and then your user is created. Once your user is created, you will see that you get an option to download your credential. So download your CSV from here and you will get your credentials downloaded. Mind it, never ever show your access key or secret key to someone or share it with them because your access key and secret key can be gateway for the malicious kind of people to hack your account or to create different kind of bills for you that you won't like. So secure your access key and secret key and never ever commit it into a version control system. Okay, so you have downloaded the credential. Now is the time to set up your credential. The simplest way that comes to your mind when you are working with Terraform is simply put your access key and secret key in the AWS provider. But remember, I just said that you are not supposed to commit your Terraform access key and secret key into the version control system. And remember, IAC is all about doing version control and creating consistent architectures. So of course, you are going to upload your Terraform code into the version control system. So never ever provide your access key and secret key in AWS provider. So what should you do? The recommended way, let's find out. So it is to install and configure AWS CLI on your system. That way, what will happen is, once you do AWS CLI install, the CLI will create the AWS secret key and access key. And in the config, it will create your reason and the output JSON. So your access key and your secret key are more secret and it gets created as part of the credentials filter. However, the less Lesser secretive things are your reasons or your output format that goes into the config. So how do you configure your AWS CLI? First, you can install your AWS CLI v2 from the document that is provided over here for your operating system, and then run AWS configure command. Once you run AWS configure command, it will prompt you to provide your AWS access key ID or secret key ID, default reason name, and output format. All right. Uh, don't worry for these access key and secret key. These are dummy anyways. As I told you, we are not supposed to see your access key and secret key, right? Then if you provide your default reason name, by default, Terraform is going to create your resources in that reason name if you don't provide any in the provider section. So the question comes, is AWS configure the best way using your access key and secret key? I would say if you are starting, it's well enough to get you started, okay? But going forward, I won't highly recommend it because lately AWS also don't recommend to use static credentials. That is your access key and secret key. And the recommended way is to use AWS SSO or the IAM Identity Center to configure your CLI. Okay, so this is not the scope of this talk, but I have given a link to the documentation that implements it. So I would highly recommend you to check later on how you can implement SSO with your CLI to create and manage your Terraform resources. All right. Okay, so when you are creating your first resources, how it goes? I have mentioned the steps. We are already on step 3 where we are authenticating with AWS using AWS CLI. So what would you do? Next, you can create a very simple Terraform configuration file specifying a simple S3 bucket, and then you can run Terraform commands, which are like init, plan, apply, destroy. These are, on the core of the Terraform. Okay. So let's see here. As you can see, I have created a main.tf, which has a very, very simple S3 bucket. As you can see, there is a resource AWS S3 bucket type, and the name is demo bucket. This is not the name of the bucket. This is the name of the S3 bucket's resource. The name of the bucket I have provided is CK demo bucket 04. So what I have done, I have just provided the Terraform declaration with the provider, which provider I am using. Then next, I am providing that how Terraform should authenticate with that provider. I have specified the default profile. And mind it, if you are not creating a named profile while creating or while configuring your AWS profile, it gets created as default profile. So if you configure your AWS profile, usually your default profile gets created. And here you can specify your AWS reason. Remember, you specified a reason while configuring AWS CLI as well. You can override that over here. If you want to create a CLI not in a default reason but in a different reason altogether, you can override that configuration over here. So once you have a very simple Terraform configuration, the next is to do Terraform init. What does Terraform init do? Now, Terraform is a modular architecture, and it only contains the Terraform binary, only contains the required code for doing the different API and all, but it does not contain any provider specific code. And it's good in a way, because you don't want the binary to have thousands of providers, do you? I'm sure no. So when you do Terraform init, by looking at your configuration file, Terraform figure out that which provider you are working with, and then it downloads all the provider specific code so that you can work with that provider. So once we run Terraform init, it says initializing the backend and initializing the provider plugin. You see, reusing previous version of HashiCorp AWS from the dependency log, whatever. So it is downloading the HashiCorp AWS provider details. And the important thing is you only do it once in your Terraform project, because once you have downloaded the provider specific code, you don't need to re-download it, right? Until unless the provider version you are changing or anything else you are changing, you only need to do it once. So once you have done with you are done with Terraform in it, you can run Terraform plan. Terraform plan is nothing but it lets you what you are going to create. For example, in our case, it says Terraform will perform the following action. AWS S3 bucket dot demo bucket will be created. And that's what we exactly want. We want to create an AWS S3 bucket. So Terraform will say that in the plan that what it is going to add. And so if you are happy with your Terraform plan, you can go ahead and you can do Terraform apply. So Terraform apply is the command that is actually going to create your resources on your provider, in our case, AWS. So you see, it will ask to prompt you that do you want to perform these actions? Only yes will be accepted to approve. So type yes and hit enter. And within no time, it starts creating your resource. See, AWS S3 bucket is still creating, and then creation completed after 12 seconds. Apply complete, resource to added. So that's how it got created. So now you have created your first resource on AWS. All right, so I'm telling you some of the important commands that will be useful while you are working with Terraform. So we have already talked about init, plan, apply. A validate is the command that lets you validate beforehand that if your Terraform configuration is going to work on or not. And that way it helps you find out error early in your life cycle. And that's really good. Then comes Terraform destroy. As you might have already guessed, Terraform destroys or deletes any infrastructure that you have created. All right. This is very handy, and very important point. If you are creating your resources for learning purpose, always make sure to run Terraform destroy by the end of the your POC or whatever you are doing, so that you don't leave any of the resources running in your account and be shocked with the end moment dollars in the bill. Okay. Next, there are Terraform FMT, which formats your code. For example, if you have written your code which is zigzag and not written in a well-defined format, so you can format your code using Terraform FMT. It helps in increasing the readability and maintaining the code for better. Then Terraform version, it lets you know which version of the Terraform you are running. And then Terraform import lets you import your already existing resources in your account into the Terraform. Now, those were not the only commands that is available over Terraform. There are many more. So all you need to do is type Terraform in your command line and hit enter. Terraform is going to show you all the available commands that is present over there. So if you can see here, it is showing the main commands are init, validate, plan, apply, and destroy. And we have already talked about it. If you see for all the command, it is showing a small description as well that what this command is supposed to do. And then there are some other commands as well that you can use, and then you can read about the description what these commands are used for and use it as per your convenience. What next? Okay, so because Terraform does not enforce you to use a ID, you can get started with a simple Notepad or Notepad++ or any simple editor that you would like, right? But in that case, your Notepad or your editor is not going to prompt you that what you should create when you have. It's not going to give you auto suggestions or to help you improve your productivity while you are creating your Terraform resource. So I highly recommend the official Terraform plugin, which is HashiCorp Terraform. to download that will help you in syntax highlighting and auto completion for Terraform. It also helps you in one more thing, which I'm going to tell you in the upcoming slides. Okay, so as I said, auto suggestion. See, as soon as you type resource AWS underscore Dyna, it lets you know all the available AWS resources that starts with AWS Dyna. That means it gives you auto suggestion. And my friend, this saves a lot of time, and also the trip to back and forth going to documentation to see what are the available resource or the parameter and then configure it. So it is going to be your savior while you are working with Terraform. So always, I recommend to use VS Code with this plugin for your Terraform development when you are actually serious about developing on Terraform. Like, Notepad or Notepad++ is okay for your first POC or your learning time. But once you get serious, I would highly recommend you to get install VS Code and then use your the auto suggestion and other benefit that it has to provide. Formatting your Terraform code automatically. Few slides ago, I talked about formatting your code using Terraform FMT. That's a manual action. You need to, run the Terraform FMT in order to format your code. That's okay. It's just a simple command. But still, as a developer, I always prefer to format my command on saving the file. For example, I have done the give it is kind of formatting, but all I would like to do is I do control save and magic. Your code is formatted with a beautiful layout and all that is required for better readability, right? So your Terraform extension is going to help you in that as well. Let me tell you how. You open the settings in VS Code and search for format. In the format, here, check this thing as format a file on save. But if you are reading this says a formatter must be available. The file must not be saved after delay and the editor must be not be setting down. So for this format on save to work, you have to choose a formatter, right? Let's go ahead and do that. Search for the formatter in your settings again, and in your default formatter, choose HashiCorp Terraform. And as soon as you choose your formatter and do your uh, format on save, you can test the formatting. For example, see how I have just made some gibberish kind of indentation in this my DynamoDB resource creation window of TF. And to test it, do these kind of random changes and hit Control S. And that's when your code gets formatted on save. See how beautiful it looks. So coming to that was about the formatting. So by now you are able to create your first resource on AWS using the best practices for authentication, staying secure by using AWS CLI, and never ever providing your AWS secret key and access key in your provider block, right? Let's see some other AWS general guidelines and best practices that you should follow. Never use your root credential for Terraform or any other work. Do not share your credential with anyone else. And a small tips is whenever you are going to implement a Terraform feature in your project, you don't know already, right? That what are the different available, parameters that you should configure. So go in console, create an EC2 instance, see what are the various options that you need to enable, and then note down the configuration that you are doing. And after that, implement the same using Terraform. It does help, it has helped me. So I hope it's going to help you as well. Then, as I already said, destroy your resource if you are doing just for learning purpose. And last but not the least, always set up billing alarm in your AWS account to avoid last minute billing socks. Okay. You can set up an alarm to intimate you via email that, okay, as soon as I reach $1 of spend, intimate me because I don't want to get billed unnecessary, right? So you should always set a billing alarm, especially when you are a learner. All right, so these are some of the resources that can help you going forward. You have started your journey, you have created your first resource, then your go-to resource will be official documentation. Whichever resource that you want to create, always follow the documentation. You can also check out HashiCorp Learn website, and there is really a good book, Terraform Up and Running, that helps. And to get started with Terraform in right way, I have written a blog post as well that you can follow. All right. So if you have any question, feel free to drop in the comments, and I'd be happy to answer. Or you can also connect me with at my blog or my Twitter, LinkedIn handle, or you can email me at the specified email. Thank you.
Awesome. Nice work, Preeti. It's always great to touch on these basic and fundamental concepts. I really liked how you kind of laid out some of the maybe not as well known Terraform commands. Like Terraform format is one of my favorite commands. And also, really cool tidbits on saving cost and making sure you're not overspending, and great tidbits there. Very good foundational talk there. So really appreciate your time there, Preeti. I can't believe it, but we are at the end of this, and we have one final speaker for the day, Saravanan Guru. He is a principal engineer at InfraCloud Technologies, a cloud native enthusiast, DevOps evangelist, and AWS community builder. He is here to talk to us about setting up GitHub Action workflow for Terraform to deploy AWS infrastructure. So kind of just building on top of what Preeti just talked about and expanding on it. So I'm really excited for this last talk of this of tonight and today. So Saravanan, please take us away.
Thanks, Hari, and hello everyone. It's nice to see you everyone in HashiTalks India, and it's my pleasure to present one of the topic for HashiTalks. So I would like to thank all the presenters throughout the day and participants who are attending the talk so far. So your questions and insights helping the session more interactive and the things actually. So let's get into my talk actually. So I'm Saravanan, and Hari has given a short introduction about myself basically. And today I'm going to talk about setting up a GitHub Action workflow for Terraform to deploy AWS infrastructure. And in the previous session, you guys have seen how to set up a workflow, how to create an AWS infrastructure using Terraform basically. So in this session, we will be walking you through the how to setting up a GitHub Action workflow for deploying a AWS infrastructure using Terraform actually. So myself, Saravanan, and as Hari mentioned, I'm working as a principal engineer in InfraCloud Technologies. I am a cloud native consultant and DevOps evangelist. I'm also a AWS community builder. I'm passionate about designing and automating the infrastructure solutions using infrastructure as a code technologies like Terraform, Chef, or whatever it is, right? And as part of my community contribution, I am contributing by writing technical blogs, and I answer for Stack Overflow questions, and I am also a OSS contributor in GitHub as well. So some of my social footprints are mentioned in the below, basically. Yeah, so that's about me. And today's agenda is so Preeti pretty much covered mostly about the AWS and what is Terraform and what are the Terraform commands and all. And I'll be presenting you through what is the context for setting up a GitHub Action workflow using for Terraform, and we will also cover a few of the use cases that would be useful for the particular scenario I'm going to present today. And then we will be having a quick code workflow walkthrough of like what is the workflow we are going to build today, and I'll just provide a demo of it actually, and then we'll move on to the Q&A section. So basically, yeah. So for context setting for Terraform and GitHub Action workflow use cases, like you guys might be having a developer team. They would be developing their code, and they wanted to test their code in real time, right? In that time, if they wanted to create an environment for testing their code specifically, they might need to reach out to the specific DevOps team or anyone to set up a pipeline for testing and deploying their code. But if we set up a workflow, whatever I'm going to present today, so the developer team can use that workflow as a ready-made thing and to deploy and test their code basically. So this workflow will spin up a Terraform environment in AWS, and it will also do the basic checking of validation and stuff actually about the Terraform code. And then if the developer team wanted to have some deployment step, that can also be added as part of the workflow basically. And another use case is like infrastructure automation development team wants to validate and deploy their automation code stored in a specific folder in the repository. So basically, like once after we created a code in code for a particular infrastructure automation scenario, if anyone wants to spin up the code from the specific directory, we will be able to do that using this workflow. So for that, actually, GitHub Action come up with one good option for like workflow dispatch actually. So in our workflow, we will be using the workflow dispatch option to know how to deploy that actually for the Terraform workflow basically. So that's about the use case context. And then we will now move on to the workflow code walkthrough. Let me open that. So this is the basic Terraform workflow I have set up for my AWS code. Basically, if you can see, this is a GitHub Action workflow. If you want to talk a bit about GitHub Action, it's also a CI/CD workflow platform basically, in which it is getting popularity recently for past few years, and it is also integrated. It can be easily integrated with GitHub, so that we can also create a pipeline by having the branch hooks in which our code is getting pushed basically. So this is the workflow. So this is the workflow. So it shows basically it starts with the workflow dispatch on which our code is going to be pulled actually. So in my demo sample, I have my code in the AWS sample / create EC2 directory, and whenever there is a main code getting pushed with the new code changes, this workflow will be triggered basically, and it will also having the basic checks like Terraform validation and build. So these are all the GitHub Action related format in which it will be having the Ubuntu runner on which our workflow will be running, and this will be the code for checking out the repository code in which our code is residing. And then I have configured my AWS credential using the repository secret basically, because we cannot have the credentials hard coded in the workflow basically, because it can be accessible by anyone in the organization. And then this is the kind of HashiCorp specific implementation for installing the Terraform actually. So HashiCorp has many such GitHub Action workflow ready to be used in the GitHub Action basically. So I am using the setup Terraform GitHub Action like marketplace plugin for installing the Terraform. So once after, if we have this line, this Terraform will be getting installed in the Ubuntu runner that is already on which our workflow is running, and then we can execute our usual commands like Terraform init, validate, and plan. So basically, in the previous session, you guys might have seen init will be downloading all the providers and dependencies into the local path, and then validate will be checking for the validation of a specific Terraform code. And if and since this is a demo purpose, I have everything in the same code basically. But if we wanted to have a feedback mechanism for if at all if it is failing for an validation, we can make it, we can do it in the GitHub action. And then once after it is been done, it will be running the Terraform plan. And since this is again like demo workflow, I have it I have commented out the Terraform apply part commented out. But in our one of the use case, we have seen if at all if a developer wanted to create a Terraform environment for them, in this workflow we can uncomment this part of the code, and then we can give it to the developer for executing the code basically. And then for a demo purpose, I also depicted how to have a Terraform destroy also in this one. So this is the high level about that workflow whatever I had. And as I mentioned,
Hey,
GitHub.
Saravanan?
Yeah.
Sorry to interrupt you there. It looks like maybe you're only sharing your PowerPoint
Okay.
screen. So
Okay.
most of what you
Yeah.
were
Sorry.
talking about the code, yeah, if
Yeah.
you
Sorry. Yeah.
no worries. I didn't want you to go any further without
Sure.
sharing
Yeah.
your code. So
Yeah. I
thank you.
just I shared only one tab basically. Sorry for that basically.
No
Yeah.
worries. Yeah, let's make sure we can see both, and I'll get
Yeah.
out of your way.
Yeah, sorry for my previous thing. Basically, I have run through entire code without sharing that. So basically, as I explained, this is the Terraform GitHub Action workflow, whatever I have created for this demo purpose. Basically, this is what I was talking about on workflow dispatch is the option by GitHub Action, in which we can provide parameters in the GitHub basically. And it will be like whenever there is a code push happens in the main, it will be running this entire workflow. And I was talking about this is the Ubuntu runner in which our GitHub Action workflow will be running. And this will be the code checkout part, code checkout part in which our code, whatever the Terraform code we are going to run, that will be getting deployed or whatever it is. Right, the further operations will be based on the code repository that is being checked out here. And I have used the GitHub AWS credential, and I have added them as a repository secrets here. So because we cannot use them as it is right in the code. And for this purpose of Terraform, I am installing the Terraform CLI basically. And so basically, as I mentioned earlier, HashiCorp has developed community plugins as well as official plugins for supporting Terraform related functionalities and Terraform products like HashiCorp Vault or Consul or Terraform. So I'm using the setup Terraform HashiCorp plugin for installing the Terraform on the workflow runner, whatever we are having here. And then as mentioned in the previous session, we can just execute the Terraform commands as it is in the run block of the GitHub action, in which first we will be running the init command, and then we are validating the Terraform code. And if needed, we can have the feedback loop here if at all if the code is failing, and then we will be running the Terraform plan. And for the purpose of demo, I have commented out the part of Terraform apply here. And as I mentioned the previous in the use case list, right? So if at all, if you wanted to create a developer environment for if we wanted to give this plugin, this workflow to be executed by a developer, we can uncomment this part of the code in the GitHub action, and whoever wanted to create an environment, they can use it. And then we are having the Terraform destroy that is also depicting the demo of how to destroy that actually. So this is the workflow I have created for this demo. And I would also like to show some of the HashiCorp's marketplace where it shows all the plugin for Terraform HashiCorp related product. So you can see if you go to GitHub Marketplace, and if you search for HashiCorp, so it has many things published by HashiCorp, and we will be also having community plugin like this one, right? So there is some developer like Bloomin Labs published the plugin for Terraform. And so like this is what it is, right? So whenever if you wanted to create any HashiCorp related product or integrate it in the GitHub action, you can just do it by knowing by searching for it in the marketplace, and you can integrate into the GitHub action basically. And as I mentioned, I have incorporated this setup Terraform code, like a HashiCorp plugin in my code. So if you go through this marketplace listing, right, so you can just see how to use this plugin into the Terraform code. Terraform, not Terraform code. Basically, how to use this code in the GitHub action, and we can just use it as it is. So in my code, I have taken this and I have used it. So similarly, if you explore this option, there are multiple ways to integrate Terraform Cloud, Terraform Enterprise, and those things of like whatever Terraform product is there that can be integrated with Terraform GitHub action. So that's about it. And for the demo, I have explained. I was telling about like no, I will just run you through the code whatever I created basically. Let me show you that. So this is the instance create EC2 instance code I have created for this demo. So basically, it has everything like I have provided variables for regions and instance count. I am setting it as true. If at all, if we wanted to have more than one instance with a similar configuration, we can do that. And I am using Terraform Provider version 3 for this demo purpose. And I have this profile and everything is being configured here. So this is the kind of code I have created for this demo. And let's see like how to run this code using my workflow. So as I mentioned previously, in my workflow dispatch, we will be providing the path of this directory so that it will pick up the code from this specific path and it will be running the Terraform code. So we will see that how to run it. So for that, we will have to go to GitHub Actions tab, and this is the workflow that I have created for AWS validation part. And if we go here, you can see a run workflow button here. If you click on it, it will be showing the TF file path in which we can change. By default, now I'm having it in the EC2 path from which I wanted to run the code. But if anyone wants to invoke infrastructure creation from another path, they can do it basically from by editing this path actually. So let's click on the run workflow. So it will start the workflow running now. So now you can see the workflow has been started. So if you click on that further, it will just do whatever we have defined in our Terraform workflow basically here, right? And one other information is like this workflow will be residing under the .github and workflow directories. So this is the code that I have walked through before. So yeah, and the workflow is running here, you can see. So now the workflow has been completed. So now we can see whatever we have written in the code has been successfully executed. So now you can see that so that setup Terraform CLI has been done, and then it has run the init plan and apply command here. And then the Terraform destroy demo has been done basically. And then it has run the post configuration cleanup and everything actually. So that is the demo part of this session. So yeah, that's it basically for today, whatever I had to present. So if at all, if you have any questions, you can just post it.
That's awesome, Saravanan. I was a little bit worried that your computer is going to die. It was slowly counting down and counting down faster than my liking, but I'm glad you made it through. And thank you for staying with us and making sure you're sharing your code as well. So I think there's a lot of people interested in your repo. Um, touching on GitHub workflow is such an important piece for today's CI/CD pipeline oriented, DevOps pipeline oriented workflows. So really nice talk. Great way to end our last talk. Um, what a phenomenal day! I've been having so much fun paying attention to each one of the talks. We've had some really good talks today. We touched on so many platforms. We started off with security, zero trust principles. HashiCorp has a nice zero trust white paper that I encourage everybody to take a look. Tanya and Amit touched on some really important concepts there around Spiffy, Spire. And then Anuj Modi also talked about automating some of those secret solutions around security. So that was pretty cool. A lot of great talks about automation in general. We saw how to do Terraform the right way. We saw how to use Terraform to build a ISO compliant data center and data recovery center. A practitioner style presentation by Ashish covering GitHub code spaces, Azure, and Terraform again, and Terraform Cloud. And also one of my favorite talks about touching on how Nomad and Console and were able to help with, Windows, which seems to be growing from a microservices footprint as well. So, and thanks to also our ServiceNow partners for touching on some of the CMDB workflows there. So many things to unpack. I hope everyone here had just as much fun as I did. Really quick reminder again, HashiTalks 2023 series continues. Our 24-hour global community event will be back for its 5th edition next month, 16th and 17th. Go to hashi.co/hashitalks 2023 to register. You can also join our HashiCorp user groups by going to meetup.com/pro/hugs. Who doesn't want more hugs, right? So you can really meet the community and get interested on if you're interested in more of HashiCorp products. And if you want to do more of the certifications and things like that as well, you can get a lot of information by meeting the community. And a big shout out to my phenomenal producer, Jasmine White, for doing all the things in the background, making this so smooth. So thank you, Jasmine. And thank you to the speakers again and the audience members. I hope everyone had a great day listening to all the talks. We will see you again soon at our next HashiTalks event. Thank you.